Hello everyone. Today we are doing Mathematics Paper 1. It is the paper from November 2023, so the final paper for Matric 2023, part of the IEB. Okay, let's have a look. So instructions: ensure your calculator is in degree mode. Well, this is paper 1, so it's not as important as paper 2, but it could still be important, so don't forget that. And then they say round off to one decimal place unless otherwise stated. Okay, so paper 1, you do the finance concepts. So when you're dealing with money, remember 2 decimal places. And thankfully, I see this year in this paper, they do tell you when you're dealing with money to round to 2 decimal places. They do remind you. Okay, so just keep an eye out for that. Let's get into it. So question 1 in section A, they tell us that we need to solve for x in each case below. So here's question 1. We have to do this. We need to solve for x, and we need to leave the answer in logarithmic form. Okay, so x is over here in the exponent place. Okay, it's over here. So if we look, our base is 3. Okay, so to solve for x, what we do is we say x is equal to log, and our base was 3. So it goes down here. And then what was on the other side? 2. So then 2 will go over there. Okay, so that is as easy as that. That is how you would do that question over there. For question 2, we're given this thing over here. So whenever we have x under square root over here, we need to be very careful. So we're gonna just keep an eye out on the steps. So the steps is we're going to get the surd by itself. Then we're going to square both sides, and we're going to get 2 solutions. Okay, we're going to get x is equal to something, or x is equal to something. What you need to do then is you need to plug that x back in here and check that the left-hand side, this side, is equal to the right-hand side. Because sometimes not all your answers will be valid over there. Okay, so not all the answers will be valid. So remember that. Okay, guys, this comes up, it's the same pattern every past paper. If you look at my other videos, or if you look at previous past papers, you'll notice this pattern where this question is always in the beginning of the paper, and this type of question. So follow the method, and remember that you need to check at the end. Okay, so don't lose marks, because this question 1 it can become an easy section if you practice it a lot. Well, I guess that's true for everything. But yes, I just don't want you guys to lose marks for this. Okay, it comes up all the time, every single time. It's almost always question 2. Well, always the second part of question 1. Okay, so don't get this wrong. Okay, now that that's out of the way, our first step is we get the surd by itself, just like this. So what happens is on the right, we now get x plus 1. So what we do now is we square both sides. So this is going to become squared, and this is going to become squared. So what happens here, this will fall away. The square root will fall away. On this side, we can write this twice and FOIL. And if you write it twice and FOIL, what you'll do is you'll get this. Now we need to solve for x, because remember that was our instruction over here. Solve for x in each case below. So we have a quadratic. So what we need to do is we need to get all the x's, well, everything on one side equals to 0. So if that comes across, that we get this. When that comes across, we get -6 is equal to 0. Okay, so this one we can factorize easily. If it wasn't factorized, if you couldn't factorize, if it wasn't factorizable, right? Factorizable, I guess, you could either use the quadratic formula or the calculator. Okay, remember, not all calculators can have that mode where they can solve for trinomials. I have a video of how you can solve trinomials easily using the calculator, if your calculator allows it. But anyways, this one can be factorized easily. It is just plus 3 x minus 2. Okay, nice and easy. X is equal to -3, or x is equal to 2. Okay, now what we need to do is, we're not done here. Okay, one of these could be invalid. So what we need to do is we need to check up here. Okay, we need to check the left-hand side is equal to the right-hand side. Okay, so if you don't have to show this in your exam. We're just going to test this. So if we look at the left-hand side, if we put -3 plus 7 minus 1, what do we get there? So that gives us the square root of 4 minus 1. So that's 2 minus 1. 2 minus 1 is 1. Okay, so this is from the left-hand side. Okay, if you look at the right-hand side here, what are we going to get? Negative 3. Okay, so we know that this answer is not valid. Okay, because the left-hand side is not equal to the right-hand side. Okay, let's check the other one. You normally don't have to, but let's check it anyways. Okay, so we're going to have 2 plus 7, or in the square root, minus 1. So this is again for the left-hand side. And if we look at that, that is the square root of 9, which is 3, minus 1, which is 2. Okay, so the left-hand side is 2, and then the right-hand side here, we just plug in there is 2. So 2 equals 2, left-hand side is equal to right-hand side. So this answer is valid. Okay, so we need to cross this one out. Don't forget to cross that out. Okay, make sure you cross it out to get your full 4 marks. Okay, let's not lose those marks, guys. All right, now for part B over here, they say solve for x and y simultaneously if, and then they give these equations. Okay, so we can solve for y pretty easily over here. So we're going to get y is equal to 2x plus 7. Okay, so I guess we could call this equation 1 if we wanted to. And then what we can do, we don't even have to label it, to be honest. So what we can do now is just write this thing over here. X squared minus x minus y minus 3 is equal to 0. And now remember, whenever we see a y, we know y can be replaced with this. Okay, but remember, let's put this in a bracket. So every time you see a y, we're going to put a bracket and then this thing. Okay, the bracket's important. You'll see why in a second. So we put minus, and then y is 2x plus 7. Okay, the bracket's really important here because this negative needs to distribute here, okay, and here. Okay, so if you just put minus 2x plus 7, that would be wrong. Okay, so I really recommend put these brackets when you substitute. Okay, anytime you substitute, not just in this section. Okay, it's super helpful. All right, anyway, so let's distribute and collect like terms. So this is what we get over here. Minus 3 is equal to 0. It's x squared minus 3x minus 10 is equal to 0. Can this be factorized? Normally, yes it can. Okay, it's just 5 and 2. So x is minus 5, x plus 2 is equal to 0. Okay, now very important, I'm going to write x is equal to 5 or x is equal to negative 2. All right, so what I like to do is I like to draw a line here in the middle. Okay, so we need to solve for x and y simultaneously. So this x is going to be related to one y solution. Okay, and this x is going to be related to another. So let's not confuse them. And at the end, let's write them in coordinate form. Okay, so let's see, how can we get y from this x? Okay, well, the thing is we have an equation here to solve for y. Okay, it's just over here. So what we can do is just plug in a 5 over here by this x. So we get y is equal to 2 times 5 plus 7, which is 17. Okay, now I like to write my answers in coordinate form. Okay, I think this is the best way to do it. So you can very clearly see that, okay, when x is 5, y is 17. Okay, so you're being very careful and sure over there that these answers relate, because remember this x is related to this y. Okay, so write your answers in coordinate form. Okay, and also what we do here, same process. So we say y is equal to 2, negative 2 plus 7. So that's negative 4 plus 7, which is 3. Okay, so this in coordinate form, remember x goes first and then the y. All right, then over here, question C, they say for what values of x is the statement true? Okay, so don't even let this English bother you over here, right? Just look at this. Okay, so it's a quadratic inequality. So what we do is we just get the x's to one side like this. Okay, and we can factorize this. So it's x, 3x minus 1 is less than or equal to 0. So what we do now is we get our critical values. So we can see our critical values are x is equal to 0 or x is equal to 1 over 3. So you might know a different method, but this is the way I do it. So what we do now is we do a number line. So 0 will be here, 1 over 3 will be here. Okay, and this, remember this thing is a parabola. This thing over here is a parabola. And you can see we have a positive in front of the x squared. So we know the shape of the parabola is going to be like this. Okay, so you can see here we're above this axis over here. So it's positive this way, it's positive. And then this way it's below this line. So it's negative here, okay? Until it goes over here to the right of 1/3, it is positive. Okay. So I hope that is clear. This is the graphical method of solving these. What you can also do is plug in values. For example, you could plug in something in between here, like something in between here would be like 1/6, for example. Because this is 0,3, you could plug in something like 0,1, for example, and then you'll see you get a negative. So the main point is there's different ways of doing it, but you should get to the same solution we get in a second. Okay, and it's asking where we're less than 0. So less than 0 means negative, less than or equal to 0, important. So it means that we're negative or 0. Okay, so you can see we're between 0 and 1/3. So you can either write it like this, x is between 0 and 1/3 included, or you could say x is an element of square bracket 0, 1/3 square bracket. Okay, so two possible ways, two ways to write it. Okay, so even if you do a different method, you should get to one of these solutions. You only need one of these, okay, but they're both acceptable. For question 2, we're given this function f. It's given by this equation over here. They say determine the coordinates of the y-intercept of the graph of f. Okay, so this thing over here is a cubic function, and we know because there's 3 x's. Okay, 3 x's, so we know it's cubic. You could also FOIL all of this out and then get the cubic equation. Okay, so in the form of ax cubed plus bx squared plus cx plus d. Okay, you could do that and then see it's a cubic, but we should be able to identify it's a cubic immediately. But we don't really have to know it's a cubic right now, because I say calculate the y-intercept of the graph of f. So to find the y-intercept, what you do is you just make x equals 0. Okay, so we just plug in zeros over here. So you could use your calculator, but essentially what you're getting is it's just 2 times -4 times -4. Okay, so those two negatives will give us a positive. 2 times 4 is 8. Oh, let's not even do that. Let's do 4 times 4 is 16. Double 16 is 32. Okay, so be careful that asks for the coordinates of the y-intercept. So x is 0 and y is 32. Okay, you don't have to show working. You can just put this down over here. Now they say determine f prime of x, so the first derivative. Okay, for 3 marks. So what I've done is I include this the function here again. So now we have to expand it out because we can't differentiate it in this form right here. Okay, not in core math. So let's expand this thing out. So what I'm going to do is I'm going to rewrite this as f of x is equal to, and then this thing is the same bracket, it's just x minus 4 squared. Okay, so I should probably be doing this over here. Let me just continue over here. Okay, so fx is equal to, so here we have x plus 2. And then if you write twice in FOIL, you're going to get x squared minus 8x plus 16. Okay, now we're just going to distribute. Let me show you how we distribute. So this x goes there to all 3 terms, then the 2 goes to all 3 terms. Okay, so this is a bit messy. So what we get there is x cubed minus 8x squared plus 16x plus 2x squared. What do we get? Minus 16x, and then 2 times 32 is 32. Okay, sorry, mind went blank. Okay, so let us collect like terms. Okay, so these are going to cancel for us. So what we're left with is x cubed minus 6x squared plus 32. Okay, so this is fx. Okay, we've just rewrote fx. Now we need to find f prime of x. Okay, so we can say that therefore f prime of x is equal to 3x squared minus 12x. Okay, so remember your rules of differentiation over there. We just bring this forward, and then -1, bring this forward, -1, and this is a constant, so it becomes 0. Okay, so essentially we could write +0, but there's no point of doing that. Okay, nice and easy, hopefully. Okay, now for C, they say for which values of x will the first derivative be equals to 0. So again, let's not let the English confuse us. All we have to do is just set this thing equals to 0. Okay, so it's 3x squared minus 12x is equal to 0. So what we can do is just take out a common factor of 3x. So what we left is x minus 4 is equal to 0. So what we have there is x is equal to 0 or x is equal to 4. Okay, not too bad. And now for D, they say on the set of axes provided, sketch the graph of f, label the following x and y intercepts, turning points or stationary points, and the point of inflection. Okay, so all of this is for 4 marks. So it's important that you know the general shape of a cubic. Okay, so here, where did we find the equation? Okay, so here's the equation of fx. Okay, let me get rid of some of this. All right, so here's the equation of fx. So we know that it's positive here in front. Okay, so what you should know is the general shape of a positive cubic will look something like this. The way I view it is a camel, right? It looks a bit like a camel. So this is how a positive cubic would look. So we know this is our general shape, more or less. Okay, but let's work out. Let's start off here with the x and y intercepts. Okay, and remember we have to label all of these. Okay, but let's plot some points that we know. So in A, we worked out the y-intercept. It was 0, 32. Okay, so we go to 0, 32. So 35 is there, 32. It'll be about here. Okay, so we have a point over there. That's 0, 32. We'll label it a bit later. I don't like to label immediately because maybe the function goes through my labels. I don't really like that. Okay, and let's work out the x-intercepts. So x-intercepts come when we set the y equals to 0. So essentially our x-intercepts will come when we have 0 is equal to x plus 2, x minus 4, x minus 4. Okay, so what you'll see here are x-intercepts is x is equal to -2 or x is equal to 4. Okay, but the x is equal to 4 is a repeated root. Okay, let's not stress about that though. Let's just have a look. We know that our x-intercepts are going to be, these are the coordinates of our x-intercepts for 0. Okay, it's the same thing we've always dealt with, right? So x-intercept, you make y 0, y-intercept, you make x 0. Okay, I hope you're seeing that it's actually quite simple. So here is one x-intercept. I know I'm labeling in orange now, but yeah. Okay, so we're labeling in orange and then for 0 over there. Okay, so we've sorted out our intercepts. Now let's see how we can find the turning points. Okay, but use what we've worked out already. We've worked out the turning points, right? We haven't worked out the coordinates yet, but we know where they occur. Okay, we know where the turning points occur. They occur when x is equal to 0 or x is equal to 4. Okay, so at this point, what you could do is you could substitute 0 into the main function to find the coordinate of this turning point, right? So if you do that, what you'll find is you'll work with this and then just substitute x is 0 over here. Okay, x is 0. And when you do that, you'll just find we've already done that. It's this coordinate over here. So we know we turn over here. Okay, so we know there's going to be some turning point over here. Okay, and we know that there's a turning point over here when x is 4. But what happens when x is 4? Y equals 0. So we've already plotted it. So we know we turn over here. Okay, we turn over there and we turn over here. Okay. So we know we turn to those points and we know that the general shape is going to look like something like this. Okay. So we know that the general shape, so we're not drawing the graph yet. I'm just showing you what the general shape is. So that we know the general shape is we turn here and we're going to turn over there. Okay, so we know the general shape is going to look like this. And this just comes from theory, memorizing that general shape. So do you see how important it is to know the general shape and the general forms? Because otherwise you would have to do a bit of other work that you're not really expected to know in core maths. In terms of determining concavity, you're not meant to know concavity that in depth, according to the SAGs for maths. But yeah, so it's important to know the general shape. So the general shape will look like this, more or less. Okay, but one thing we haven't done yet, okay, so we have the coordinates for x and y intercepts, we have the coordinates for the turning points. Now we just need to find point of inflection. Okay, so to find the point of inflection, what we do is we have to find the second derivative. Okay, we need to find f prime, f double prime. So f double prime. Let me use a different color. So basically you just take the derivative of the first derivative. Okay, so you just do x double prime. Okay, so if you just differentiate this thing, so that becomes 6x minus 12. Okay, so that's the coordinates for, sorry, not the coordinates, this is the equation for the second derivative. So to find the point of inflection, we set this equals to 0. Okay, so what you do is you just say 6x minus 12 is equal to 0. You can do this on some spare paper because they don't exactly ask for the working. But anyways, what you're going to get is 6x is equal to 12. So x is equal to 2. So we know that the point of inflection is when x is equal to 2. But now what we have to do is we need to plug 2, this 2, back into f of x. Okay, so back into f of x to get the coordinates of the point of inflection. Okay, but before we do that, let's just have a quick discussion. So you don't really have to know this in depth. Okay, I don't think some schools will discuss it because it doesn't come up that often. But I want to discuss this a bit in depth, point of inflections, and then what I'm going to do is I'm going to give you a piece of advice that if you don't understand what I'm saying here, a general rule of thumb. Okay, but I think it is important to know what I'm about to explain over here. Okay, let's actually go to a new slide. Okay, so we just found that f double prime of x is equal to 6x minus 12. Okay, and what we did when we set this equals to 0, we got x is equal to 2. Okay, so when we set this equals to 0. So what this is saying is there's a possible point of inflection here. So it's not always a point of inflection. It's a possible point of inflection. Okay, so I want you to think of a number line. Here we have 2. So if it's a point of inflection, the second derivative is going to change signs from this side to that side. Okay, so what is a number to the left of 2? 1. A number to the right of 2? 3. Okay, so this thing will be a point of inflection if the second derivative changes sign. Okay, if it changes sign. So what I mean is, what we're going to do is we're going to take f double prime and we're going to substitute 1 in there and see what sign we get. Okay, so remember here it's just 6, and here we're just replacing x with a 1, right? Because normally this is f double prime of x, but now it's 1. So every time we see an x, we put a 1, minus 12. And what you see, what we'll get here is negative 6. Okay, so we know that when we're to the left of 2, we get a negative. Okay, so just stick with me for a second. Now what we do is we're plugging in a value to the right of 2, we're plugging in 3. Okay, so whenever you see an x, we put a 3, minus 12, so that's 18 minus 12, which is 6, positive 6. Okay, so do you see how the second derivative has changed signs? Okay, when it's to the left of 2, it's a negative, and when it's the right of 2, it's a positive. So that means that this is a point of inflection. Okay, so normally you have to do this test to determine if this is a point of inflection. Okay, I don't know how many schools discuss this, but this is an important check you have to do. Okay, so it's not always the case that if you set the second derivative equals to 0, and then the number you get will be a point of inflection. It's not always true. You first have to do this test. Okay, when you check to the left and the right of this point of inflection, the possible point of inflection. Okay, so that's my general advice. I would follow that. I don't think they will give you a I don't think they'll give you something like this where it's not actually a point of inflection. So my rule of thumb would be that if you don't understand this, or if you're not, if you feel a bit uneasy with this, don't worry about this. Just assume that this is your point of inflection. But this is the proper way to do it, and probably the safer way. Okay, that would be my advice. All right. So anyways, so we've determined now that this is a point of inflection. So what we have to do now is determine the coordinates of this point of inflection. So what we do now is we substitute 2 into our function f, not f double prime, f. Okay, so remember our function f was, it's over here. Okay, so what we're doing is we're just substituting a 2 over there. So the function, I'll write it for us over here. So I'll write f of x above here. So f of x is equal to x plus 2, x minus 4, x minus 4. Okay, so let me just change color here. So what we're doing now is f of 2. So whenever we see an x, we replace with a 2. So that's 2 plus 2, 2 minus 4, 2 minus 4. Okay, so that gives us 4 times negative 2 times by negative 2. So the negatives sort themselves out. So that's 4 times 4, 16. Okay, so we know that at 2, 16, this is our point of inflection. Okay, so what we can do now is we can do a rough sketch of our function. It'll look something like this. There's our point of inflection over there. Okay, so again, it's not perfect, my drawing, but this is how it would look. Okay, now remember label. Don't forget labeling. Okay, it's really important. So this is the point minus 2, 0. This was the point 0, 32, which was also a turning point. This is also a turning point. This is a x-intercept and also a turning point of 4, 0. And then do not forget, label the point of inflection, which we got as 216. Okay. 216. Okay, and that is how you would plot this is how you would plot f. Let's just also label this as function f. Okay, so I hope I've been making sense. Let's do this last one, and they say for what values of x is f of x greater than 0. Okay, so let's whip out the ruler. Okay, let's get it vertical. So remember so this is interesting, whoops. You can solve it algebraically, which I think I'll show you how to do that, but I also want to show you visually, because visually is the easier and quicker method that I do recommend. But let's go back to the question. They're saying for what values is the function, the y values of the function bigger than 0? Okay, so they're saying when is our y bigger than 0? Okay, the y values of our function f. Okay, so over here, our y's, you see how these y's are all negative? Okay, and then from here, they start going positive. Okay, so remember they're just asking for y values. So here our y's are negative, 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 negative. Here, our y is 0. Okay, let's see, are we allowed to be 0? Yes, okay, because it's bigger than or equal to 0. So here, we're bigger than 0, we're positive, 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 still positive, positive. Here we go 0, and then we're just always positive. Okay, so whenever we're bigger than negative 2, bigger or equal to negative 2, then that statement is true. Our y values will be positive. Okay, so what you can say is x is bigger than or equal to negative 2. Okay, again, you can also put it in interval notation. It would just be negative 2 all the way to positive infinity. Okay, that's infinity sign. All right, let me fix it. Okay, but remember, we can never include infinity, because as soon as you get to the biggest number, there will always be one bigger. Okay, so as soon as you get to infinity, there'll always be a big number bigger than that. Okay, that's why we can never include it. It's elusive. Okay, then I said we can do this algebraically. You could do it algebraically. So in this case, it's actually not that easy to do it algebraically. So what I mean is, what I'm meaning to say is, remember our f of x is, where was it? Our f of x. This is our f of x, right? Okay, and it's also here. And it's also here in the top right. So to solve it algebraically, what I'd mean from that point is you would be solving, essentially you would be solving this. You'd be solving that x minus 2, x plus 4, x plus 4 is greater than equal to 0. So what you do is, it's kind of just like when you have a quadratic inequality, you look at your CVs, x is 2 or x is equal to -4, then you plot your number line. Here is, sorry, this should be -2. Yeah, so I messed up here. I wrote it wrong. Sorry, it should be x plus 2, x minus 4, x minus 4. So that should be a plus. So here's -2, here's 4. So the thing is, it's a trinomial, sorry, it's a cubic. So what happens is it kind of, we know it looks like this. Okay, so yeah, I know it is a bit confusing. But yeah, so you can't really solve it algebraically over here. It's just better to look at the function. But sometimes you can solve it algebraically if it is a cubic, sorry, if it's a quadratic function. Okay, but I recommend just looking at your graph. For question 3, we're given two graphs, f and g. They've been sketched on the same set of axes. So they tell us f is this graph over here, so it's a log graph, and then g is the straight line graph over here. So this is g, they tell us this is g, so that's our straight line graph, and then this is our log graph. So they say b and c are the x and y intercept of the graph of f, respectively. So basically b is x-intercept, c is y-intercept of f. They give us the coordinates of a, okay, it lies on f and g, so it's a point of intersection. And then they say the dotted line through D is, with equation x is -2, is the asymptote of f. Okay, so we know that this line equation x equals -2. Okay, so let's see what they're asking us. They say f of x equals log m x plus 2, determine the value of m. Okay, so that's basically what they told us over there. So it's the same equation. We need to work out the value of m. So what we need to do, sorry, I skipped the question there. What we need to do here is we need to solve for m. So there's one unknown, but what we can do is we can plug in a point. Okay, so let's try plug in a point. If we plug in 1 is equal to log m x plus 2, but now x is 3 plus 1, sorry, x plus 2, like that, all right? So this is what we're trying to solve. So that's 1 is equal to log m of 5, okay? So if we want to get rid of this log m, what we have to do is put everything to base m, okay, base m. So here we put base m to the power of 1 is equal to, if we put this to base m, this falls away, okay? So what we get is m to the power of 1 is equal to 5. Okay, so therefore m is equal to 5. Okay, so that's how we would solve that. Okay, you could also kind of do this by trial and error by just testing a few of these. But yeah, I prefer the algebraic solution over here. Okay, so there's m. So now we know the equation of f, which could be helpful. Now they say determine the coordinates of b and c if m is 5. Okay, so they told us m is 5. That kind of could have guided you over here. Okay, but anyways, let's have a look at this. So b is the x-intercept and c is the y-intercept. Okay, so let's start off with b. To find b, it's the x-intercept, so we set y is equal to 0. Okay, so for the x-int, okay, we get 0 is equal to log 5 of x plus 2. So we're trying to solve for x, we set y equals 0. What we do now, we set everything to base 5 again. So 5 to the power of 0 is equal to, that will fall away, x plus 2. Anything to the power of 0 is 1. So here we have 1 is equal to x plus 2. So x is equal to -1. Okay, so very important, give the coordinates though. So b is the point -1, 0. Okay, now to find c, so c is the y-intercept. So to find the y-intercept, what we do is we set x is equal to 0. Okay, so we get y is equal to log 5, 0 plus 2. Okay, and when you do this we're going to have to put in our calculator. Because if you do log 5 of 2, it's not really clear what that is. So let's put it in the calculator. right? I should be in calculator view now, perfect. So log, okay, not that log, right? Because this log is base 10. We have a different base, so we have to do this one. Log base 5 of 2, which is to 1 decimal place, that is 0,4. Okay, to 1 decimal place, 0,4. Okay, so 0,4. So the coordinate of C then is, C is the coordinate 0, 0,4. Okay, so I hope you guys are following along over there. So luckily I've been better about being out of the calculator view today. But anyways, there we have B, and here we have C, the coordinates, okay, for 4 marks over there. Now they say for what value / values of x is this statement true? Okay, so g of x bigger or equal to f of x. Okay, so g is a straight line. So we need the straight line above the log graph, okay, above. Okay, so let's bring out the trusty ruler. Let's actually bring out the ruler over here. Okay, so it's bigger. So remember, we're looking for the straight line above the log graph, okay, because remember gx is a straight line and f is the log graph. Okay, so you can see that the graph of f only starts existing from this point, -2 onwards. Okay, only to the right of -2, so it doesn't even exist that x is -2, remember, because that's an asymptote. Okay, but you can see just from the right of -2, g is above. Okay, because what I'm going to point out over here is you can see here's g. Okay, there's a y value of g, and then for example here's the y value of f. Okay, and you can see here is g and here's f, so you can very clearly see that g is above. But if you look at the y value of this, I don't know, let's call that 20, and then this, for example, could be -15, and you can very clearly see that the y value of g is above the y value of f. Okay, so this is true, that f of x is less than g of x at this point, or g of x is above f of x at this point. Okay, so remember, that's what we're checking. We're just checking y values. Okay, or you can just say, where is g above f? Where is g above f? Okay, so g is above, g is above, g is above, g is above. Let's not confuse ourselves now, because f starts moving above the x-axis, right? But we're not concerned about that. We just care about, is g above f? So g is still above, g is still above. Let's not let the y-intercepts bug us. G is above, g is above, g is above. Okay, here, what happens is g starts going below. Okay, so f starts going above. Okay, from this point over here, when x is equal to 3. Okay, so let's recap. For what values of x is the statement true? Okay, so we know when we're just to the right of -2 up until 3, okay, including. Okay, so we can include -3, okay, because here the graphs are equal. Okay, and we're allowed to be equal because of this little thing here at the bottom. Okay, so what I'm going to do is I'm going to put this in interval notation. Okay, so from -2. The reason I'm putting a round bracket is because f can never be -2, right? Because that's our asymptote. Remember, the equation of this line is x is equal to -2. All right, this dotted line. So if we're just to the right of that, then f starts existing. So then g can be above it. Okay, hope you guys follow that. And then up until 3. And we can include 3 because at that point the graphs are equal. The graphs intersect at this point. Okay, so that would be our answer for C. Okay, that would be our answer for C. This one, there's no way, well, very difficult to solve it algebraically. Yeah, it would be very difficult to solve this algebraically. Okay, so just solve it graphically. Okay, let me not even get that in anyone's minds. Anyways, let's move over to D. Let's say on the same set of axes, we need to sketch the graph of f -1, so the inverse of f. We need to label the intercepts, asymptote, and the point where the functions are equal. If the inverse function is equal to g of x. Okay, so what we can do is, if we look at f of x, all right, so remember f of x is log 5 x plus 2. Okay, so how we can rewrite this is y is equal to log 5 x plus 2. So what we can do is now, just for the inverse, obviously we just swap the x and y. So we're going to get x is equal to log 5 y plus 2. And we want y by itself, so we put everything base 5. So we get 5 to the x is equal to y plus 2. So we're going to get y is equal to 5 to the x minus 2. Okay, so what you can do from this point is you can use this equation. And from this equation, what you can do is you can find out the intercepts, the asymptote, and the point when these graphs are equal. Okay, but very interesting, when you inverse a function, everything swaps. The x and y swap, right? That's what we saw here. The x and the y swap. But what's important is all the coordinates swap. Okay, so what I mean with that is what was the x-intercept of f before is now going to be the y-intercept of the inverse. So let me repeat that. So when we inverse, right, the x and y swap. So before, when we're dealing with f on this side and f minus 1. So when we're dealing with the normal function, the x-intercept, right, when we inverse it, now becomes the y-intercept. Okay, so the x-intercept of f becomes the y-intercept of the inverse. So what do you think happens with the y-intercept? It becomes the x-intercept of the inverse. What do you think happens to the asymptote, right? So the asymptote, in our case, right, for f, was x equals negative 2. Remember, because this was over here. Okay, so it was x is equal to negative 2. Remember, but what happens now? X and y swap. So what's going to happen now is we're going to have a horizontal asymptote at x is equal to negative 2. And you can see that came in over here as well. Okay, so my main point here is you just swap things. Okay, you literally just swap things. It's that easy. Okay, so let's go and have a look over here. Okay, so b we know is the point minus 1, 0. C is the point 0, 0, 4. Okay, and we know that G and F intercept at 3, 1. Okay, now we need to deal with the inverse. Okay, so you don't even have to show working for any of this. Okay, the most important here is we need to label these things, the intercepts, the asymptote, and the point where these things are equal. Okay, so that's where we get our marks. We don't get marks for working. Okay, so for the inverse, right? So let's have a look. So the asymptote of f, right? So here's f. The asymptote of f is x equals negative 2. So what's going to happen is the asymptote. This is the asymptote of f. The asymptote of f is x equals negative 2. Okay. So the asymptote for our inverse is going to be y equals negative 2. Let me plot that in. Okay. It'll be roughly about here. Okay. Let's label the asymptote. Y equals negative 2. Okay. Then the x-intercept of f was negative 1, 0. Okay, so then the y-intercept of the inverse is going to be, you remember we swap our x and y's. Okay, so it's going to be 0, negative 1. Okay, you with me there, guys? Okay, so I'm going to just move this a bit because I need to put this over here. Okay, because here's 0, negative 1. Okay, this was negative 1, 0. So do you see how things are just flipping? Okay, here was the y-intercept of f. Okay, so that y-intercept is going to correlate to our x-intercept for the inverse. Okay, so remember we swap these. Okay, we swap these. So the x-intercept is now going to be 0, 4, 0. Okay, we just swap those coordinates. Just as easy as that. So that would be 0, 4, 0 would roughly be about here. So I got to move this again because it's kind of in the way of what I'm trying to do over here. Okay, so we have the asymptote, we have the x and y intercept. Let's see what else they required. That is literally it. Now we just got to sketch the graph. Okay, so this graph, if you do the inverse of a log graph, the inverse of a log graph is an exponential graph. Okay, so you could have realized that by doing this, okay? Or you could have just known that the inverse of a log graph is a exponential graph, okay? So how this graph will look in general form, its general form is, it will look something like this. Okay, it'll look something like this, and it has the asymptote at y equals negative 2, which we knew already, okay? So that's how we can sketch from this point. Remember, you could also use your table mode if you were not exactly sure of the shape. Okay, so here we go. This is the graph of the inverse. Okay, and this goes on over there. We just got to label the x and y intercept. So this is the point 0, 4, 0, and this is the y-intercept of 0, -1. Okay, remember it's just this swapped. Okay, so there you go. That is literally, oh, one thing I missed. Okay, one thing I missed. But this is the general shape. One thing I missed from the question is this over here. Okay, we had to label, let's see, we've labeled the intercepts, we've labeled the asymptote, but we have to label this. Okay, the point where the inverse is equal to g of x. Okay, but this is also easy, flipping easy. Okay, because this is where f is equal to g. 3, 1. So where do you think f, the inverse of f, is going to be equal to g, right? We just swap it. This is 1, 3. How easy is that? Okay, it's just that easy, flipping easy. So that's how you do that. Okay, what I will say is doing this step is helpful to know the general shape of the inverse. Okay, to know the general shape of that. Okay, instead of memorizing that log, the inverse of a log function is an exponential function. This, I will admit, is quite a helpful step. Okay, but remember, you can just flip the coordinates. Okay, but if you wanted to work with this and then find the y-intercept by setting this equals to 0, you can feel free to do that. Okay, but you'll get the same coordinates that we got over here. All right, so hopefully that was interesting and you learned something there. So let's move over to question 4. We need to find f prime of x and g prime of x respectively for each of the following. Okay, so here is f of x. It's given in this weird form. Let's write it in a form that is useful for us. Sorry, I was yawning. So we need to rewrite this. Okay, so we can rewrite this by saying f of x is equal to x to the power of 2 over 5 minus 3x to the power of -3. Okay, now it's in a nice and easy form for us to work with. So let's do f prime of x is equal to, we bring that to the front, 2 over 5x to the power of 2 over 5 minus 1 minus 3, we bring our -3 forward, x to the power of -3 minus 1. Okay, so what we did is we just brought that forward over there, multiplying, and then minus 1. Okay, so just our normal rules for differentiation. Okay, so that's 2 over 5x, 2 over 5 minus 1, that just gives us minus 3 over 5. You feel free to use your calculator over there. And over here, we're going to get plus 9 x to the power of -4. Okay, they don't say leave your answers with positive exponents, so feel free to just leave it like this. Okay, nice and easy. Just put it in a form that is easy for us to work with. Same thing over here for G. Okay, so some of the AP Math students, or what they call it further study maths now. So some of the further study math students might be tempted to apply a quotient rule over here. I would not recommend it. What I'd recommend is use math core and differentiation techniques in the math core exam. Okay, so what we need to do is, this is not in a nice form. Okay, this is not a nice form. So let's make it into a nice form for us. So let's factorize the top. Let's do that. Let's factorize the top. Okay, so g of x is equal to, so what we get at the top is x minus 1, x minus 1. Okay, you can also write that x minus 1 squared. Okay, at the bottom, if we factorize that, x minus 1, like that. So what's going to happen is these are going to cancel. So what we're left with is g of x is equal to 1 over 4 times by x minus 1. Okay, so I hope you see how I did that step. Writing it as a fraction in front is going to make our lives a lot easier. I'll show you why in a second, because now let's distribute this in. We get -1 over 4x minus 1 over 4. Okay, and now they ask us to differentiate g of x. So we need to do g prime of x is just equal to 1 over 4. Just like that. Okay, remember this will become 0, and then this is currently to the power of 1. We bring that forward, -1, you'll see 1 minus 1 is 0. Okay, so technically we have x to the power of 0 here, but it's just 1. Okay, super easy. So the main thing is you just need to fight to put this in a form that you've seen before and can differentiate. Okay, that's the tricky bit over there. Okay, let's move over to B. They say the following information is given for a function f. They give us this information here, and they say determine the equation of the tangent to f at x is equal to 4 in the form of y equals mx plus c. Okay, so what's important here is don't let this information confuse you. Okay, I know it looks in a bit of a weird format over here. It does look a bit weird, but let's break it down. Okay, step by step. That's the tough part with these things. You need to understand what's going on. Okay, but take it one piece at a time. It makes it easier to deal with it. Let's look at this first bit of information. They're saying that f of 4 is equal to 5. Okay, so what they're saying there is they give you a coordinate. They say, okay, when x is 4, right, because normally what we have is f of x, right? We normally have f of x, but what they've replaced this x with is just a 4. Okay, so when they're saying that when x is 4, our y, because remember f of something is just equal to y. Okay, so they're saying, because remember f of x is just y, f of x is just y. Okay, so they're saying when we have, when we plug in a 4 here, right, when our x is 4, our y, remember here's our y, is 5. Okay, so you see how they're giving you a coordinate here. They're giving you the coordinates 4, 5. Okay, they've given us the coordinates 4, 5. That could be useful. Okay, okay, that could be useful because remember we, to find the equation of a straight line, what is that pen? Okay, to find the equation of a straight line, we need a point and a gradient. Okay, we need a gradient and a point. So here's our point. This could be helpful. Okay. And what is important here, they say, determine the equation of the tangent to f at x equal to 4. So we have a point on the tangent, which is this, because remember this is our x when x is 4. Okay, so that is helpful. Okay, that's our first bit of information. The second bit of information, be careful, this says f prime of 4 is equal to 7. Okay, but remember, what does f prime of x represent? Okay, if I plug in an x here, what it does is it represents the gradient. F prime of x is my gradient. Okay, my gradient of the tangent. So if I do f prime of 4 is equal to 7. Okay, so what this is saying is when my x, right, this is my x, when my x is 4, my gradient is 7. The gradient of the tangent is 7. So if you look at this equation, we know m. We know m is what? 7. Because it comes from this. Okay, so what we have is, you didn't even have to write any of this stuff over here. Okay, you didn't have to write any of this. This was just me explaining. Okay, so let's get rid of this and let's have a look what we have to do. So what we have is y is equal to 7x plus c. But now what we're doing is we're just substituting a coordinate which was given to us, 4, 5. So we get 5 is equal to 7 times 4 plus c. So what we do is we just take the negative 28, well, we take the 28 to the other side, it becomes a negative. So what we do is we get c is equal to negative 23. Okay, very important though, they want the equation. Okay, so as I've said before in a whole bunch of other places, don't forget to rewrite this in full. Okay, they want the equation, not just the little pieces of c, they want it all together. So this is the equation of the tangent to f at x is equal to 4. All right. Now they say using first principles, find h of x if hx is this thing over here. Okay, so over here is the formula for first principles. But what I like to do is I like to differentiate this normally first using our normal rules. So we can check our answer at the end. Okay, so if we do normal rules, okay, you don't show this on your page, but if we do normal differentiation of this, you can see that, well, that's a constant, it's going to fall away. So we know at the end we need to end up with h prime of x is equal to 5. Okay, so that's going to be our final answer. Well, it should, if we do everything correctly. Okay, So remember, our first step is we're going to have to do this x plus h thing. Okay, but instead of f here, we're dealing with h. Okay, don't let that confuse you. It could be g of x, it could be f, it could be, in this case, it's h. Okay, so don't let that stress you out. Let's do, so I'll write h of x here for us. H of x is equal to 5x minus 8. Okay, so what I recommend doing is, I always like to do this first. Do this x plus h thing. Do that first before you start jumping into the question. Okay, so what this means is, whenever we had an x before, whenever we see an x now, we need to replace it with x plus h. Okay, so what we do is we say 5, and we say, oh, here's an x. So I replace it with what is ever in here, which is x plus h minus 8. So let me distribute that in, 5x plus 5h minus 8. Okay, no common factors, so I leave it like this. I just leave it like this. Now I apply this formula. Okay, we're looking for h prime of x. Okay, and that's equal to the limit as h tends to 0. So remember, this limit thing needs to stay in all the way until the end, until we substitute h equals 0 in. But anyways, let's just write the formula in full in terms of h's, and then we'll substitute in. Okay, over h. So I hope all these h's are not confusing, right? So remember, this is not h times these things, it's a name, right? So it's g, it's a function. This is a function g of x. Okay, so hopefully this is not confusing. But anyways, so limit as h tends to 0. So we wrote the formula in this step. So now let's fill in over here. What is x plus h? And that's what we have over here. This thing over here, right? So this is x plus h. All right, so I put that over there. It's 5x plus 5h minus 8 minus, okay? And now I need a minus hx. Okay, so it's minus hx. So what is my hx? This is my hx. Okay, but remember, we put a bracket, and this is hx, 5x minus 8. Okay, then all of this over h. So what I do is, I still haven't applied the limit. I need to just look for like terms at the top. So hopefully things are going to cancel at the top, and then I'm going to take a common factor. Maybe, we'll see. So anyways, what I get at the top is these things are going to cancel. This is going to cancel with that. Okay, but let me write it in full. Let me write it in full and in a different color. So we're going to get 5x plus 5h minus 8 minus 5x plus 8 all over h. Okay, so what happens now is, you'll see that this can cancel with that, this can cancel with that. So what we're left with is, if we move over to a new slide, is this is equal to the limit as h tends to 0, and you'll see what's left is just 5. Sorry, this falls away as well. So it's just 5h over h. So 5h over h. So what we can do now is, we don't even have to take our common factor, because these can just cancel. Okay, so what happens now is, it's the limit as h tends to 0 of 5. Okay, but you see, if we plug in h over here, there's no way to plug in an h, so we don't even need this. We just know that, well, therefore h prime of x is equal to 5. All right, was that what we were expecting? Was this the final answer we were expecting? Let's check. Yes, it was. Okay, so we know we applied our steps, all of these steps correctly. Okay, cool. So again, that comes up time and time again, so don't let this cost you marks. For question 5, they tell us that we're dealing with an arithmetic sequence, and they give that sequence below. So obviously very important, they tell us it's an arithmetic, so keep a close eye for that. All right, and they say determine the number of terms in the sequence. So we're solving for n. Okay, the birds are going crazy. They just love arithmetic sequences, obviously. Anyways, let's have a look. So we know that in this sequence, we know that this is the last term. So let's deal with the general term. Tn is equal to a plus n minus 1 d for arithmetic, right? So we know that d, if you say this minus this, and that minus that, you can see that we're adding 3 every time, right? So our D is our D is 3 and A is 22. So we can say that Tn is equal to 22 plus n minus 1 times 3. So that's 3n plus 19. So this is the general term for the sequence, but we also know that for this sequence, this is the last term. Okay, so to solve for n, we know we need to solve for n. To solve for this last term, we know that 262 is equal to 3n plus 19. Now we just need to find out what that term number is that is equal to this. So if we do this, we take that 19 to the other side. So 262 minus 19 gives us 243. 243 is equal to 3n, so we just divide by 3. And what we're expecting is a natural number. Okay, so it can't, in this case, if you do something and you get like 81,23, you know you've done something wrong, because it needs to be a natural number. So 1 to positive infinity, so 1, 2, 3, etc. Yes, so that is the answer over here. So there's 81 terms in this sequence. All right. Now for part B, still using the same sequence as you can see up here. They say represent the sum of all the terms using sigma notation. Okay, so remember this symbol here is sigma. It's a Greek symbol. So it's sigma, and what we do is in here we put the formula for the general term. So remember here we put Tn. Okay, here we say n is equal to 1 because that is where we start. And up here is the last term in that sequence. 81 would be the last term. Okay, so if you had to sum all of these, this is the formula that, this is representing it in sigma notation. Okay, before we can get into question C, I made a mistake in question B. This should be plus 19. Okay, it should be plus 19. Because over here it was 3n plus 19. So I think in the previous one I put a negative here, which is a mistake. I should have been put plus 19. So now that that's out of the way, let's look at question C. They say if the pattern continues, determine the smallest number of terms that must be added to the sequence above so that the sum of all the terms will be more than 15,000. Okay, so the thing is here we need to work out the smallest number of terms that must be added. Okay. So that the sum of all the terms is more than 15,000. Okay, because remember here, this is representing a sum. So it's saying if we add all of these. Okay, so let me show you something. I don't think all calculators have this feature. Okay, this sigma mode over here. Okay, so what I'm about to do in the calculator, so if I do 3x plus 19, okay, so I'm using x here because the calculator requires it as x. Okay, here we're using n. Okay, but anyways, there we put 1 and there we put 81. So when I press equals here, what the calculator is doing is it's adding all of these 81 terms together. And when we add them, we get 11,502. Okay, so what that means is when we add all of these, we get 11,502. Okay, and you can see that they want to get to 15,000. Okay, so if your calculator doesn't have that sigma mode, what you're going to have to do is use this formula for the sum of arithmetic terms. Okay, n minus 1 d. You're going to have to use this equation for the sum to work that out if your calculator does not have that sigma notation. Okay, yes, so let's have a look at that. So we know that the first 81 terms, if we add all of the first 81 terms, right, we get this 11,502. Okay, and here are the first 81 terms. Okay, we knew this is the 81st term because we calculated it here in A. All right, and we know if we add 81 terms, we get 11,502. Okay, but we want to keep going, right, with the sequence. Okay, and we want to find out how far we need to keep going. We need to find out how many terms that still need to be added so that the sum of everything is more than 15,000. Okay, so essentially what we're doing is we have this sum, right? This is the sum of the first 81 terms. It's 3n plus 19. All right. we have that. We know that this comes to 11,502. Okay. But to this, we need to add some other sum, all right? A sum of some other terms so that we are more than 15,000. Okay. So we are more than 15,000. All right. So essentially what we have is this. Okay. So we know that this is 11,502. So if I take that to the other side, I get 15,000 minus 11,502. That gives me 3,498. Okay, so I know that if I continue this pattern, right? So if I keep continuing with this pattern, I have 265, 268, remember because we're adding 3 every time, 271, etc. Okay, I want to find out how many more of these I have to add until I get to 15,000. Okay. But what I know here is the sum of these terms has to be greater than 3,498. Okay, so the sum of these terms has to be more than 3,498. Okay, so let me work with the sequence that we see over here. Okay, so what is my difference between these terms? It's still 3, right? Okay, so D is still equal to 3. But now be careful, what's my first term? This is my first term. 265. Okay, so what I'm going to do is I'm going to be applying this formula, right? This is the sum of n terms, but now just with the sequence. Okay, so let me fill that in. So n over 2, I'm just going to write the formula first for us. Okay, so here's the general formula, 3498. And what I'm going to do now is fill in what I know. Okay, so I don't know the number of terms. Okay, what I do know is my first term was 265. My A is 265. So 2 times 265 plus n minus 1, and my constant difference is 3. All right, and then that sum needs to be greater than 3,498. All right, so what I can do now is multiply both sides by 2. So I'm going to be getting n is, if you double 265 times 2 is 530. So that gives me 530 plus 3n minus 3. And then this side, what I'm doing is I'm timesing both sides by 2. Okay. So what I'm saying is 3498 times 2. So then I get 6996 on this side. So I distribute this in, right? But what I can do is I can collect like terms here. So then this becomes 527. So what I get is 3n squared plus 527n is greater than 6996. But what I can do is I can take this to the other side. So that becomes a minus, and now that is greater than 0. Okay, so what I can do now is we either are going to have to use the quadratic formula or use the calculator. Okay, so if your calculator has this mode, it's super helpful. But essentially what we're doing is now we go mode equation, so 5, and then 3, because that's a trinomial form. So we put in our coefficients, 527 minus 6996, and we get our answers. Okay, so I'm going to go do a new page, new slide for us. So our critical values are n is equal to, and what was that n? 12,4, 12,4, or n is equal to, and our other critical value is negative 188,1. Negative 188,1. Okay, so what we do is we do our number line 188,1, and here we have 12,4. So remember, it's just a normal quadratic inequality. This is a positive, so we know the shape is like this. Let me at least try to go through there. Okay, so the shape's like this, so we know it's positive, negative, positive. Okay, and we need to be bigger than 0. So we need to be in these positive regions. Okay, so we either need to be this side or this side of, either to the left of negative 188 or to the right of 12,4. All right, but remember, n has to be a natural number. It needs to be 1, 2, 3, 4. It can't have any decimals, right? And it can't be negative. So we know that this is not valid. Okay, and we know that 12,4 isn't valid, right? So what we have to do is we actually have to add 13 terms. Okay, so we're going to say that therefore 13 terms will have to be added. Have to be added. Okay, let me change view. Have to be added. Okay, so let's just do a quick recap over there. So we know that, let's read the question. Okay, so we know that if we sum 81 terms, okay, if we sum 81 terms, we get 11,502. But they don't want that. They want us to be more than 15,000. The sum of everything would be more than 15,000. So now we need to work out how many more terms do we need to then get us to 15,000. Okay, and we worked out that the sum of these terms needs to be more than 3,498. So then what we did is we applied this formula for the sum of n terms, right? It's just this formula. And what we looked at is if we continue the pattern, now we're at 265. Okay, this is our new sequence that we need to keep adding. Okay, so it's 265. So when we solve this, we get this expression over here. Okay, which is just a quadratic inequality that we solve like this. But the thing is, we can't have a negative n, okay? And n cannot be a fraction, can't have a decimal, okay? And we have to be to the right of 12,4, and the next whole number, or natural number, is 13. That's why it's 13 terms will have to be added, okay? Because let me show you something on the calculator, okay? So if we have the sequence, all right, so it's 3x plus 19, all right. We know that if we did it to 81 terms, if we sum the first 81, we're short, 11,502, okay. But now let's say I add 13 terms, right? I know that this sum has to be more than 15,000, okay. If my working is correct, this will be more than 15,000. And you see that it is, all right. So, but let's see what happens if I only added 12 terms. If I only added 12 terms. So if I rounded this 12 down, I would have got 14,880, which is not more than 15,000. Okay, so I know this was a bit of a tougher question, but I hope my explanations weren't too complicated, and I hope this made sense. If you have any more questions, feel free to let me know in the comments. All right, moving over to question 6, to finance. So we invest into 2 different investment schemes for a period of 5 years. So here we have investment 1, so 3,500 Rand into investment at the end of each month. So you can see here, this is going to be future value. And the interest is 15% per annum compounded monthly. All right. Then investment 2, we make a deposit of 24,000 immediately, and then the second deposit 7,000 at the end of the 3rd year. Then the interest is this, compounded quarterly. And it says if you combine the value of the 2 investments at the end of the 5-year period, then what is the value of this lump sum? Give your answer to 2 decimal places. Okay, so here they tell us 2 decimal places, but we know we're working with money, so mostly it should be 2 decimal places. Okay, in the past they didn't always tell you 2 decimal places when dealing with money. Okay, but money 2 decimal places. Anyways, let's tackle investment 1. Okay, so 3,500 Rand into investment at the end of each month, and they give us the interest rate over there. So we know we're going to be using the future value formula, okay, for investment 1. So I'm going to write out the future value formula for us. Okay, over I. This is the future value formula. All right, it's future value because we're dealing with investments. So the future value of all these payments is 3,500 Rand. Then over here is 1 plus our interest rate is 15%, compounded monthly, so we divide by 12, and then 12 times by 5 years, okay, because that's how many periods it is going to be compounded. And then here at the bottom, it is 15 over 12, 15% over 12. Okay, and if we put all of this in the calculator, I'm going to show it all in the calculator. So 3,500 1 plus 0.15 over 12, and then that's to the power of 12 times 5 minus 1, And then if we go down here, 0.15 divided by 12. Okay, close all of that. And we get 310. Okay, so to 2 decimal places, it is 310,010, comma 77, I believe. 78. Okay, 78. All right, so this is just for investment 1. So I think it's useful to split them. That's why I've split them in my calculations here. So yeah, essentially this is investment 1. Now let's look at investment 2. All right. So this one isn't future value because we're not making regular payments every month. So let's draw a timeline. Okay. So it is for 5 years. Okay. So here's our timeline. So T0, T1, T2, T3, T4, T5. Okay, for 5 years. So let's see. We make this deposit immediately. 24,000 Rand. Okay, so that we put that into the account. All right. And then we make a second deposit. So we're putting money into the account at the end of the 3rd year. Okay, so end of the 3rd year, where do you think that is? Pause and have a think. Some people will put it here by T2, but it's actually over here by T3, 7,000 Rand. Because let's have a look. From this time to that time is 1 year. So this is the end of the 1st year. 2nd year, end of the 3rd. Okay, so T3 is where the 7,000 goes. Okay, because from here to there is 1 year. So 1 year, 2 year, 3 year, end of the 3rd year. Okay, hope everyone's fine with that. Okay, so we have that, and sorry, I bumped the mic. Interest on investment is 20% per annum compounded quarterly. Okay, so the interest rate doesn't change. It's just constant for these 5 years. So let's look at these two investments. So we know that A is going to be equal to, so let's look at the 24,000 Rand first. Okay, so the 24,000 Rand, so what we're using this formula for compound interest, P1 plus I to the N. Where's that formula? Yeah, just this. Okay, so 24,001 plus our interest rate is 20% compounded quarterly. So we say 4 times 5, because this 24,000 Rand was in for 5 years. 1 year, 2 year, 3 year, 4 year, 5 years. Okay, cool. Then what we're going to do is we're going to add the 7,000. Okay, and the 7,000 is at the same interest rate, compounded quarterly. And now the thing is, this one's only in for 2 years. Okay, because end of the 3rd year, so it's there for the full 4th and then for the full 5th. So what we're doing is we're saying 4 times 2 years. Okay, and what happens is if we add these together, all right, let's go to the calculator view. So if we add these, what we're going to get, so I mentioned in another video that storing values, it was in my last video, the 2023 November Maths Paper 2 paper. I mentioned something about storing values, so I'm going to show you how it's helpful here. Okay, so you see how this thing comes up twice, right? And it's 1 plus 0.2 over 4. Okay, so what I can do is I can just store this as A. All right, so have a look at this. I do 24,000 times by A, and A is to the power of 4 times 5, plus 7,000 to the power, times A to the power of 4 times 2. And what I get there is 74,021. Okay, 74,021, comma 33. Okay, so you'll see if this, it comes in quite handy over here, especially in grade 11 when you do more complicated timelines and you sometimes run out of space. But here is a perfect example where you could use the store feature. It's super helpful at times. So yes, that you can see if you did it the normal way, you would get, you should get the same answer. All right, but anyway, so what we need to do now is we need to be careful. So we split these investments, right? To work them out individually, but if you combine the value, then what's the value of the lump sum? Okay, so what we need to do is we just need to add them, right? Pretty simple. So what we can do then is we could say, therefore, lump sum is, and what we're going to do is we're just going to add the values in our calculator. Okay, so we're going to take this thing plus the 310 010.78, and this is the answer we get. This is our lump sum. Remember, 2 decimal places, and we're dealing with money, so let's put the rand symbol, 032,11. Okay, let's check with the memo. Yes, the memo gets that exact answer, maybe with the not so weird over 3. Okay, so I hope that made sense. Let's make sense. You with me, we're in finance, so I guess it has to. Okay, sorry. Anyways, B. New question. Okay, it's not related to the previous one. So it says to start your ice cream business, you take out a loan for 250,000 Rand. The bank offers an interest rate of 10% per annum compounded monthly. Okay, it said, how much should you pay each month if you would like to pay off the loan at the end of 10 years? If the first payment is made at the end of the first month, give your answer correct to 2 decimal places. Okay, 2 decimal places. All right, so at the end of the first month, this just meets our normal criteria for future value or present value. Okay, in this case, it's present value because we're dealing with a loan. Okay, so yes, that just means we don't have to do anything fancy with our present value formula. Okay, am I on the right screen? No, I'm in calculator mode. Okay, cool. So this is just a normal present value where we're working out, we're trying to work out how much you should pay. All right, so we're solving for X in our present value. Let me show you the present value formula. It is given by this. It is on your formula sheet. I'm just rewriting it for us. So they just have P. Okay, so I know before also here I had FV. You can just write F. Okay. The thing is it's present value, so I sometimes write PV. But anyways, so this is the formula from your formula sheet. So I'm just copying it. Over here we have negative N. Okay, don't forget that negative over I. All right, so let's see, we have to find out how much you should pay each month. So X, we need to solve for this thing over here. Okay, and we know our time periods, it's end of 10 years. Okay, we just need to be careful with that, you'll see in a second. And we know our present value, that's just the loan amount over there. All right, so let's fill in everything we know. So 250,000 is equal to X, which is what we're trying to solve. And then we have 1 minus 1 plus I, which is 0.10, compounded monthly. So we put 12. And then what we do is we say negative 12 times 10 for 10 years. Okay, because each year there are 12 periods, compound periods, and there are 10 years. Okay, so you could also put just negative 120 because there's 120 compound periods. Okay. So I know some people do this differently, but I hope my way makes sense. All right, or at least you can understand my way. Okay, so we have this. So what I would recommend is do all of this thing in your calculator. I'll show you, and then we just say 250,000 divided by whatever this was in our calculator. That'll be the easiest way. Let me show you. So what we do is we're going to put this in our calculator. So what we're going to do is we're going to say 1 minus 1 plus 0.1 over 12, or 13 over 12. And then all of that's the power of negative 120 over 0.1 over 12. Okay, so I get this thing. So now what I'm going to do is say 250,000 divided by this whole thing to get X. So I say 250,000 divided by that answer. So this is my X. Okay, my monthly payments needs to be 3,303.77. Okay, the X is 3,303.77 Rand. Okay, 2 decimal places. Okay, don't forget to 2 decimal places. Okay, so that is how much we're going to have to pay if we want to pay off this loan in 10 years. All right, then for part 2 of this, they say if we decide now to pay more, if we pay 6,000 Rand per month, only starting at the end of the second month. Okay, so end of the second month, there's some weird things going on with our present value. Okay, then how many payments will be needed to pay off the loan? Round off to the nearest number of payments. So here we need to solve for the how many payments. So for n, we need to solve for n, the number of payments. Okay, So also what happens here is if we're only starting at the end of the second month, what happens is that loan amount grows for a month before we start paying it off. Okay. So before, how we had 250 on this side, what's going to happen now is we're going to have to grow that by 1 month. Okay, that 250 is going to be grown by 1 month. So let me show you what I mean. Okay, we say 250,000. So what we're doing is we're essentially still applying the present value formula, right? So we're still doing present value is x 1 minus 1 plus I to the negative n over I. Is that the present value from? Yes, that's the present value. So we're still applying that, but what happens is our present value grows for a month. Okay, and it grows by, with this interest, 10% per annum compounded monthly. Okay, so it's 0.1 divided by 12, and then here it is for 1 month. Okay, so for 1 time period. Okay, that's how much the loan grew. Okay, because it was the end of the second month. All right, over here, have a look. If the payments made at the end of the first month. Okay, so here's different, end of the second month. Okay, hope you guys are with me there. Then, now remember we're still applying this formula. So now our monthly payments are 6,000 Rand. Okay, 1 minus our interest rate is still 10% compounded monthly. But now what we're doing is we're finding negative n. Okay, so we want to find out how many payments, right? So we can put negative n over here, okay? Some people might be saying, okay, but why don't you put negative 12n? Both are fine, okay? But you need to interpret the answer. If you put negative 12 times n, okay, or negative 12n, this n that you're going to get is in terms of years, okay? Because remember, if you look back how we've been using this n over here has been for years, okay? But they want how many payments. So I know there's a lot going on the screen here, but they ask how many payments. So it'll be easier if we just put negative n, just negative n over here. That'll give us the number of payments, okay? But if you put 12n, what you're gonna have to do is just times your answer at the end by 12 to get the number of payments. Anyways, let's keep going like this. All right, so what I'm going to do now is I'm going to do this in my calculator and then divide by this. Okay, let me show you in the calculator what I'm going to do. So I'm going to say 250,000. I can also just do this. It's 250,000. I take that divided by, oh no, sorry, it's 250,000, right? And what I do is I grow it for a month, 0.1 over 12. Okay, all of this is to the power of 1. I don't really have to write that. Then what I do is I divide by 6,000. Okay, so I'm going to leave this as a fraction. So on this side I get 30, what did I get? 3025 over 72. And then that is equal to 1 minus, and I'm going to put these together. Okay, so in the calculator I'm going to say 1 plus 0.1 over 12. And that gives me 121 over 120. Okay, so I have 1 plus, wait, I just did that, right? So yeah, so this thing in the bracket just becomes 121 over 120, okay, to the power of negative n over 0.1 over 12. Okay, so what I'm going to do now is I'm going to times both sides by this. So in my calculator, what I get is 3025 over 72 divided by this thing, which is 0.1 over 12. Okay, so I should be timesing, sorry. I should be timesing, and I don't even need these brackets. Okay, I'm timesing both sides by this because it was dividing on this side. Okay, it was dividing here. To get rid of it, I need to times it on that side. Okay, so I get 605 over 1728, I think it was, 1728. Okay, I recommend leaving all your answers as fractions here, otherwise you're going to be rounding too much. Okay, you're going to be rounding too much at every step. All right, so let's evaluate. Now on this side, we have 1 minus 121 over 120 to the power of negative n. So what I can do is I can get rid of this 1. and take it to the other side by minusing 1. So what I can do is I take this answer over here and I just minus 1 from it, and I get negative 1123 over 1728. 1728 is equal to negative 121 over 120 all to the power negative n. Okay, so let's move over to a new slide. So what I'm going to do, divide both sides by a negative. So I basically just get rid of that negative. So I have I have 121 over 120 to the power of negative n is equal to 1123 over 1728. Okay, and now I'm going to have to use my log laws. Okay, so I'm going to get that negative n is equal to log of base 121 over 120, right? This is my base to the power of negative n. So if I do log, I have to do log of this base. Okay, 1123, 1728. All right, so what I'm going to do now is just put this in my calculator. Okay, so here I have this. Let me just times that. Oh, let me just even do this. So 121 over 120, and then in here goes 1123 over 1728. Put that in the calculator, and I get that negative n is equal to, what did I get? Negative 51,93. Negative 51,93. Okay, so therefore n is equal to 51,93. All right, but remember, what did the question ask? It says we need to round up to the nearest number of payments. Okay, to the nearest number of payments. Okay, so what we're going to say then is, therefore, the number of payments is number of payments is 52. Okay, or essentially 52 months. Okay, because we're making these payments every month, right, per month. Okay, so what would have happened is, if you had negative 12n over here, what would have happened is you would have got your n to be, it's just going to be this divided by 12. Okay, so you're going to get negative 51, or just 51.93. Let me show you the calculator. You're going to be getting 51.93 divided by 12. This is what you would have got in the calculator if you were working with negative 12n. So careful now, this is the number of years. Okay, this is the number of years, but they ask for the number of payments. So what you're going to have to do is, you need to realize that this is the number of years, but I make a payment. I make 12 payments every year, so I have to times this by 12. And then you're going to get the same number over here, that 52, when you round it up. Okay, that's why I prefer to use negative n over here. Always just negative n, because that'll give you the number of payments. And you can convert that into years easily if you want to. So we are moving over now to section B. And the first question we have here is question 7. So they say, if x squared minus 16x plus 73 is equal to a x minus m all squared plus p, then determine the value of m and p. So there's two ways you can do this. I'm going to show both. I'll start with this turning point way. So if you look here on the right, this form is the equation of parabola in turning point form. And to get into this form with a normal trinomial, like we have here on the left, what we have to do on the left is you have to complete the square to then get it into this form. Okay, so what we're going to do is, on the left, we're going to complete the square. Okay, so completing the square, what you do is you keep the sign, you halve that, which is 8. That's all squared, plus 73. And what we've created here is a positive 64, so we need to take it away, okay, because 8 squared is 64. So what we get then when we do that is x minus 8 all squared, and then this should give us what does that give us? 9, 11? It gives us 9 plus 9. So 73 minus 64 is 9. Yep, confirmed using the calculator. So there we go. So in this form, you can see immediately that, well, so we can say that m is 8 and p is equal to 9. Okay, so that's one way you can do it, by just completing the square. Another way you can do it is by expanding the right out. All right, so this way I'm about to show you now is a bit more of a complicated way, but if we work over here and I expand that out, so I'm going to get a, and then if I write that twice in FOIL, so what I'm going to get is 2mx plus m squared plus p, and then if I distribute that a in, what I get is 2amx plus am squared plus p. All right, so what we do now is we compare to the left and we look at coefficients. Okay, so well, we can see that if we compare coefficients here, so here we have x squared and there we have x squared, so we know that a is equal to 1. All right, because we're comparing coefficients. Then what we also have is we have negative 16 is equal to, so that was in front of the x. So here we look what's in front of the x, and here we have 2am in front of the x. Okay, so we know a is 1, so we can kind of just replace this with a 1 over here. So what you'll see is that we still get m as 8. All right, then with the constants, we have that 73, right, is equal to the constants over here. So this is our constant, it doesn't have anything with x's, so that's am squared plus p. Okay, but we know that a is 1 and m is 8, so this is 64 plus p. And then if we take this to the other side, you'll still see we get p is 9. Okay, so that was two ways to do that problem. Okay, I wanted to discuss both because I thought both of them were interesting. Okay, moving over to b. So they say that 2x is equal to k, and they want us to determine all of these followings in terms of k. All right, so very important in terms of k. So we need to look at this form and look back at our base form and somehow augment this base form so it looks like this. Okay, so that is a lot of words. Let's see how that works. Okay, so over here I need to rewrite this 2 to the power of 2x. I need to start with 2x. Okay, right, because that's my reference. So what you'll see in terms of exponent laws, it's just 2x squared. Okay, because this is going to distribute over there, power to a power, you multiply. Okay, so but the thing is, I know 2x is k. It's given up here. So this is just k squared. All right, then for this one, it's a similar thing. Okay, so I'm going to start with 2x, and I see, well, over here, I'm going to have to the power of 1 over 3. Okay, because when that distributes, then I'm going to get x over 3. All right. So this I can just write as k to the power of 1 over 3. Okay, then number 3 up here. Let's split this. Okay, so that's going to give 2 to the negative x times 2 to the 1. So I want to rewrite this as 2 to the x. All right, so that's 2 to the x to the power of minus 1 times 2 to the power of 1. So that's just going to be k to the power of minus 1 times 2. Okay. So you can also write this as 2 over k if you prefer, but this form is perfectly fine for your mark. Okay, and then all of that was for 3 marks. Okay, so every one of them was for 1 mark, so don't overthink it too much. All right, then very important here, before I discuss C, well, before we do C, I want to discuss one thing. So it's very important that you learn your log laws. Okay, just like with exponent laws. So for example, when we deal with exponent laws, we know that x to the a times x to the b is just x to the a plus b. All right, and there's a whole bunch of different laws for exponents. Okay, and what a lot of students don't do or learn or revise properly is your log laws. Okay, so for example, some of the log laws is when you have log p of, let's say, x minus log p of y, that we can rewrite as log p x divided by y. Okay, so yeah, so these are the log laws over here that are some of the log laws you're expected to know. So I got this from chilimath.com. Okay, so it's not my own, but the main point is you're meant to know these. Okay, so it doesn't come up too often, but you are required to know these. And you're going to see that when we do this problem over here, we're going to use these facts. Okay, it's going to be super helpful for us. Okay, so make sure you do know these. Okay, and what I was talking about over here relates to rule 2. Okay, so keep this at the back of the mind as we tackle this problem. Okay, so we have to solve for p over here. So let's see how we can rewrite this. So we have the same base. Okay, and what we have then is these two exponents. Okay, so base 3, and these exponents. So we know when we have the same base and we're dividing things, what we do is we minus the exponents. So what we can do is we can write this as 3 to the log p, not lob. So log p of 2 minus log p of 8. Okay, so 3 to the power of all of this. Okay, this is just our exponent laws. So it's a mix between exponent and log laws here. Okay, just like if we had 3 to the power of 2 divided by 3 to the 8, we can write that as 3 to the power of 2 minus 8. Minus 8, excuse me. Same thing going on here, right? And if we look at the right-hand side, right, so we're just taking this piece by piece. I know it looks weird. We're just taking it piece by piece. So 9, obviously we know that's 3 squared. Okay, so what we need to do then is we have the same basis. So what we can do is we can equate the powers. Okay, so we have log p of 2 minus log p of 8 is equal to 2. Just a normal exponential equation over here. So, but the thing is now, when we minus logs, okay, when we minus logs, we divide the things in the middle. So when I mean in the middle, I mean we divide these things. Okay, so when it's a minus, we divide them. Okay, so let me show you what I mean. So this came from the rule 2 log thing that I was showing earlier. Okay, so we can rewrite it as a single log like this. Okay, which is super important. Okay, so obviously 2 over 8 is just 1 over 4. Okay, 1 over 4 is equal to 2. So now what we do is we want to solve for p. So what we do is we put everything to base p. Okay, base p. So what we're going to get is 1 over 4 is equal to p squared. Okay, so we get that. So what we can do now is we take the square root on both sides. So we get p is equal to plus or minus 1 over 2. Okay, but we need to be careful here because we can't do log of a negative base, right? So we can't do log of this. We can't do this, right? So let me show you in the calculator that this will give us an error. Okay, let's move over to calculator view over here. So if I do log over here of negative 1 over 2 of 2, you see I can't do this. This is a math error. Okay, so you can't have a negative base. Okay, we can't have a negative base. So one of these answers is not allowed, it's not valid. So what we can say is therefore p is equal to a half. Okay, because if we look at the left hand side, all right, so if we look at the left hand side, if we do 3, so yeah, 3 to the power of log a half to the power of 2, sorry, not to the power, so we put the number in there 2, and then 3 to the power of log a half, and then the number over here is 8. What are we expecting? Well, that should be equal to 9, and that's what we get. But you'll see that if I try to do negative a half, okay, so if I treat that answer when I was dealing with, if I treat that p as a negative half, you'll see I just get a math error. Okay, so we're not allowed to have a negative base over there. Okay, so one of the answers was not valid. Okay, but if you got to this point over here, that's pretty good. You probably would have got 3 out of 4. Okay, so I still think that's good because it's a relatively challenging problem. Okay, so that might have caught you out at the end, but just remember we can't have this. This is not allowed. You can't have a negative base over here. Okay, question 8. We are given a hyperbola as fx. Fx is 12 over x for x is greater than 0. So here we have f. So that's our hyperbola. And they say g is the axis of symmetry for f. So here we have g. So very important, g goes through the origin. Okay, so we know immediately the equation of g is y equals x. Okay, because its y-intercept is 0. Okay, so that could be helpful. And B is the point where F intersects G. Okay, so that's where the axis of symmetry intersects F. So we know we can find B immediately, right? So what we can do is we can solve for X is equal to 12 over X to find B. Okay, so we're thinking about all these things when they give us the information. Okay, H is a tangent to F at C. So here's H, straight line, it's a tangent over there. So we might have to do some derivative over there to find the gradient of the tangent. And then they say A is the y-intercept of H, which you can see over here. Okay, so let's actually get into the questions. They say write down the equation of G. Okay, super easy, y equals x. Okay, because it intercepts here at the origin. Okay, so for B, they say determine the coordinates of B. Leave answers in third form. Okay, so remember B, they say here, is where F intersects G. So point of intersection, we're going to have x is equal to 12 over x. So what we do is we multiply both sides by x. So we get x squared is equal to 12. So what we're going to get is x is equal to plus or minus 12. Okay, square root of 12 rather. And so obviously we know that this x we're dealing here with b has to be positive root 12. Okay, because the other one would be, it would be down here at negative root 12. Okay, so, but we're dealing with the positive one because b is obviously on the positive side. Okay, so they want the coordinates of b. So what we have to do is we need to plug in this x, we need to plug in that x is equal to the square root of 12 into one of these equations, this one or this one. So obviously it'll be easier here. So if we plug that in, you can just see that, because remember we have the equation for g is, so here's the equation of g, y equals x. Okay, so to find the y coordinate of b, so the y part of the coordinate, we can just substitute it into g. Okay, so the coordinates then of b are going to be root 12, root 12. Okay, so I hope that makes sense. So obviously to get the y part, we need to sub it into one of our equations, and it'll just be easier to sub it into g. All right, for C, now over here for 8 marks, big question. They say determine the area of ACO if hx is given by this equation. Okay, so let's first identify where is this triangle ACO. So here we have A, we go to C, and here's the origin O. So this triangle, I want the area of this triangle. Okay, so let us think some ways to get area of a triangle. So obviously we have that, obviously we have the base form, right? So the area of a triangle is a half base times height. Okay, that's one form. Another form is we have area is equal to a half AB sine of angle C. Okay, so that's an option. So what we could do is work out this angle, this length, and this length, so they can then get the area. Okay, so which one requires more work? Okay, it's obviously this one requires more work. All right, so let me just re-add our triangle over here. So if we look at this one, all right, let's think of our approach. Okay, so it's 8 marks. We need to think of an approach for the problem. Let's think through this one, a half base times height. Well, if we work out AO, the length of AO, this will be our base. Okay, then if this is our base, what's our height of our triangle? So the height will be the perpendicular distance to C, this perpendicular distance. Okay, So that this over here will be our height, h. Okay, let's not confuse it with the graph called h. So I'll just write height here. Height. I think I spelled that correctly. All right. So we need a few things here, right? So we need the distance AO. AO. So let's think how we can get AO. So A is the y-intercept of h. So if we can find the y-intercept of h, then we have AO, which is the first part of, it's the space. Then let's think about this height. How can we find this height over here? Well, if we know the x-coordinate of C, then that x-coordinate is going to be equal to the height. Okay, so there we have some things to think through, right? So we need to find the coordinates of C, because that will give us our height, and we need to know the coordinate of A, because that will give us our base. So let us think through how we can do that. Okay, let us think through. So let's try find the coordinates of C. All right, so we have some information about h. We know this about h. They give us this information. So we need to find C, okay, because C will then give us the coordinates of A. But remember, to find the full equation of a straight line, we need two things. We need the gradient, which was given, and we need a point on the line. Okay, the thing is we don't have a point on the line because we need C or some other point. Okay, C will probably be the easiest. Okay, but let's think about this. How our biggest stumbling block here is we need the coordinates of C. So let's see how to get that. Okay, so we know that we might be stuck here. Okay, but let's think about what information they gave us. Okay, let's have a look at this interesting little bullet point over here. That might be a bit small, so I'm going to go over here. They're saying h is a tangent to f at C. Very important. We say we needed C, right? That's our whole thing. That's our whole thing. We needed to find C. So we look, what information do we have about C? And you can see here, h is a tangent to f at C. So this is the key we need to unlock C. All right, that was intentional. Okay, so we need to use this fact. All right, so let's think about that. Let's think about that. We know that h is a tangent to f at C. So if we know fx is given by this, 12 over x. Okay, I'm going to rewrite this as 12 x to the minus 1. Okay, and we know at C, we know what the gradient is. So we know that at some unknown x, we know that the gradient is equal to 1 over 3. Okay, because it's given over here. H is a tangent. Okay, h is the tangent. So we know this fact over here. We know the gradient is negative 1 over 3 at this x. So what we need to do is we need to find f prime of x and then set that equals to 1 over 3, negative 1 over 3, to find the x coordinate of C. All right, so if we look at f prime of x, we're just working over here, it's going to be negative 12 x to the power of negative 2. Okay, so we're going to set that is equal to negative 1 over 3. So what we're going to have is negative 12 over x squared is equal to negative 1 over 3. Okay, so what we can do here is we can just cross multiply. So what we're going to get is x squared is equal to 36. Okay, so x is equal to plus or minus 6. Okay, so obviously the x coordinate of C then is 6. Okay, we don't even, well, we're going to need the y coordinate. Okay, so to get the y coordinate of C, we just plug it into the equation of f. So what we're going to do is we're going to plug in 6 into f, which is just going to be 12 over 6, which is 2. Okay, so therefore the coordinates of C, which we struggled to get, well, when I say struggled, we fought to get to it, is this. Okay, 6, 2. Okay, so that's some important information. We know our height. We know that this now is 6 units. Okay, because from here to there is 6 units, and then here to there is 2 units, but we don't need that 2 unit part. Okay, because we're looking for this height in this triangle. Okay, now we just need AO. Okay, so we just need to find this y-intercept. Okay, which is pretty easy. We just use this equation and then substitute in the coordinates of C. Okay, so what we're going to do is we're going to say that 2 is equal to negative 1 over 3 times by 6 plus 2. And why did I say plus 2? Sorry, this is plus C. And what we get then is that's 2. So C is equal to 4. C is equal to 4. So what we know now is this B is 4 units. This is 4. So we have everything we need to solve for the area of the triangle. So area of triangle ACO is equal to a half base times height, which is a half. Our base is 4 and our height is 6. Okay, so that is 12 units squared, 12 square units. Okay, that is how we would do that question over there. So what I hope you saw, the technique we did is we asked ourselves, we went through the method. Okay, we looked at this triangle and we said, okay, what approach do I want to use to determine this area? What approach do I want to use? And we thought through a valid method, right? We thought through this equation for the area of a triangle, which is a basic concept, right? This is just a basic formula. And then we looked at the pieces and we said, how do I find the base? Or what even is the base first? And we said, okay, the base is AO. Then we said, okay, how do I get the height? And we realized the key, the roadblock for this problem that I've discussed before, how a roadblock that we need to get past is C. C was the roadblock that we needed to get past to then unlock the rest of the problem. Okay, and when you get to this point and you think, okay, how do I find C? And you think all the different methods, go back to the information. Go back to the information they gave us. Go back to the things you've solved in B and the things you've solved in A. Okay, sometimes that is helpful. In this case, we didn't use that information, but sometimes it's helpful. Okay, so don't stop. You fought so hard to get to this roadblock. Don't give up here. Think about how you can find C. Look at all the information they gave you to get past that roadblock. Okay, so I hope that explanation was helpful. Okay, so the steps we went through this problem is really important. Okay, so do not give up. Think about C. C was our stumbling block. We needed to get it. It was the key we needed to unlock this problem. So fight for that information. Think about everything you possibly can to get C. All right, don't give up there. That's the key. You need to fight through that. Okay, you need to fight for that information to unlock the problem. Okay, and you need to be like a detective. I've spoke about this before in other videos, but you need to collect all the information you can to then get C. Okay, so even if you need to write in a bullet pointed list, like a little step-by-step thing, like being a detective, what do we know about C? What information can we use? And you just keep twisting that Rubik's Cube until everything clicks. Okay, but you're making educated choices to get towards C. Okay, so yes, I know I'm taking extra time to explain this, but please guys, it is so important to go through these steps. So I hope me going through the sort of problem solving thinking is quite helpful over here. It comes up all the time, guys. So it's really important you develop that ability. Okay, so I know it takes time and I know it takes a lot of effort. So I know it's not easy. Okay, but I really want you to develop that. It's super important. It'll make your life easier. Okay, let's move over to question 9. And again, we're going to be applying those sort of techniques here again. Okay, those problem solving techniques. In question 9, they say in the Cartesian plane below, a piece of rope is hanging over the top of 2 vertical poles, A, B, and C, D. So key information. We're going to use this. Super important. They say the poles remain vertical at all times and are 5 meters high, 5 meters in height. All right, so 5 meters. Okay, so immediately here we know that the y values of both of these is 5. Okay, we don't know the x values, but we know their y values are 5 units. They say the horizontal distance between B and D is 12 meters. They give us that over there. And they say point E, 1, 2 is the lowest point of the rope. Okay, so this is the lowest point, 1, 2. Okay, so they say if the shape of the rope between points B and D is modeled by this equation, then determine the value of A. All right, so we know we have, this is a parabola. Okay, and we know that this point over here is 1, 2, and then we have this information, this is the y these are the y coordinates over here, the y part of the coordinates. Okay, so we have some information. We know the distance between these 2 points is 12 meters. Okay, but we know that the turning point, this is the axis of symmetry. The turning point is the axis of symmetry. Well, yeah, through the turning point is the axis of symmetry. So we know that this distance is 6 units, and also that this distance is 6 units. Okay, so we actually know the x part of these coordinates. So if I say 1 plus 6, I'll get that this is 7, 5. And if I do 1 minus 6, I will get that this is negative 5. Okay, so what I can do now is, obviously I know P and Q. All right, so I say that y is equal to x minus 1 squared plus 2. Okay, so it shouldn't be a bracket there. So I know this, but the issue is I need a coordinate. And the thing is I have 2 possible coordinates. Okay, so that was my stumbling block. I needed one of these coordinates. Okay, so we fought to get that over there, just like in the previous question. So what we're going to do is we're going to let's just sub this one. A 7 minus 1 squared plus 2. Okay, so I substituted in the coordinates of D. So what I'll get there is 3 is equal to 36a. So a is equal to 1 over 12. Okay, so that's how we would do this problem over here. Then for B, they say if pole CD is shifted to the right, then what should the horizontal distance be between the 2 vertical poles AB and CD become, so that the value of A is this, and the lowest point of the rope is 4 meters above the ground. Okay, so what's happening is CD is shifting to the right. Okay, so this vertical thing is going to move to the right. And what happens is now the turning point is, we have some extra information. So essentially now we have this pole over here, which is AB. And what happens is now pole CD is moving further apart. So here's CD. But what happens is now the rope is kind of like tighter. Okay, so it's not hanging as low as it did before, but we know that the lowest point is 4 meters above the ground. Okay, because remember, here's the ground. Okay, so, and here was our y-axis over here. Okay, so the thing is, what we know now is we know this y coordinate is 4. Okay, this coordinate, remember AB does not change, so this is still negative 5, 5, I believe it was from the previous question. Yes, okay, because AB is not moving, CD is moving to the right. Okay, and so we have some of this information, but what we need to do now is we need to work out this distance between B and D. Okay, but remember, this is our axis of symmetry. So if we could work out this x coordinate, all right, this x part of the coordinate, we can then work out the distance from B to D. Okay, so let's write what we know in terms of turning point form. So we have ax minus p squared plus q. So we know some information. They tell us a, and we know q. Okay, so we can sub that in, a, and okay, but a is 1 over 100. We know that, they told us. X minus p, we don't know p, but the q is 4. Okay, so if we can use this equation to solve for p, that will be the key that we need to find, if we know this distance over here. So say, for example, we have this coordinate over here is now 2, for example. We know that from B, and let's call this E again. So from B to E will then be 7 units. So this will be 7, so this will be 7. So now the distance between them is 14, for example. Okay, so we need to find this value of P over here. Okay, we need to solve for P. So we need to substitute in a point over here. And we're going to substitute in B, because B did not change. B's coordinate did not change. CD is being shifted, so we can't substitute this in, but we can substitute B in, because B does not change. Okay, so we're substituting in this, 1 over 100. Our x is now minus 5 minus p squared plus 4. All right, so what we have is 1 is equal to 1 over 100, and what we get here is 25 plus 10p plus p squared. Okay, times by 100. So what I'm going to get is 100 is equal to 25 plus 10p plus p squared. So this is just a normal quadratic. So what I'm going to get is p squared plus 10p minus 75 is equal to 0. Okay, so we're solving for p. So what I can do is I can use my calculator. I just go mode. So remember, you could use a quadratic formula or your calculator here. So I go mode 5 for equation, 3 for quadratic, and the coefficient of p squared is 1, then 10, then negative 75. So I press equals. So one of my possible p's is p is equal to 5, or p is equal to, and let's see what the other option is, negative 15. Okay, negative 15. Okay, only one of these are valid. Okay, so remember, p is this value, this x coordinate over here. So it has to be 5. Okay, the reason it has to be 5 is if it was negative 15, that would mean this point shifted this way. Okay, because remember, this initially was 1, 2. So it would have shifted to the left, but it can't shift to the left because CD shifted to the right. Okay, so this answer of p is equal to 15, negative 15 is not valid. Okay, so this is not valid. Okay, so we know p is 5. All right, so we know that this value over here is 5. So what's the distance between b and this 5? 10 units. Okay, so then this distance is also 10. Okay, so be very careful. They said, what is the horizontal distance between the two vertical poles? What is that distance? So it's 20 meters. Therefore, distance between poles is 20 meters. Okay. Question 10, they say a pool is being filled up by a hose pipe. The rate of flow increases by 10% each hour, and the table below illustrates this process. So you can see the time here, hour 1, 2, 3, 4, and the rate of flow 1, 1,1, etc. They say calculate the rate of flow during hour 24. Assume the geometric pattern above continues. Very important, geometric pattern. So we're going to be using our equations for geometric patterns, right? So essentially what they're asking here is they're asking for T24. What is the 24th term? So if we look at the formula for a geometric pattern, it is given by this. Okay, the general term for a geometric pattern. So what is our A? So we know A is equal to 1. Okay, so A is equal to 1. We got that from here. So to work out R, what we do is we take T2 divided by T1. So that's T2 over T1, which is 1, 1, 1, over 1, which is just 1, 1. Okay, so we have that Tn is equal to 1, 1 to the power of n minus 1. Okay, so therefore T24 is equal to 1, 1 to the power of 24 minus 1, which is 1, 1 to the power of 23, which is, let's just get to it in the calculator. It is 1, 1 to the power of 23. So remember the instruction was to 1 decimal place. So this is going to be rounded to 1 decimal place is 9 liters. 9 liter per minute. 9 liters per minute. Okay. My handwriting there is atrocious, but anyways, then for question 2, let's say if the hose pipe above is filling up the pool, then how many liters of water would be in the pool at the end of 24 hours, assuming the pool was empty at the start of the process? Okay, so essentially what they're asking for here is the sum of the first 24 terms for this geometric pattern. So for a geometric pattern, the general formula for the sum of n terms is A r n minus 1 over r minus 1. Okay, so to work out the sum of the first 24 terms, what we do is we say 1 1 to the power of 24 minus 1 over 1 1 minus 1. Okay, super easy. Now we just plug this into the calculator. So what I'm going to do is just do 1 1 as my answer. So what we get is ons to the power of 24 I should have this minus 1 over ons minus 1. Okay, so to one decimal place, that's going to give us 88.5 liters. That is how many liters will be in the pool. Okay. Okay, but we need to be careful here, because here the rate of flow is 1 liter per minute. Okay, so the key here is per minute. Okay, so what we actually have to do is times this by 60. Okay, we need to times this answer by 60. So what we got in the calculator, we need to times this by 60. Okay, and this is actually our answer. Okay, which is 5309.8. Okay, so therefore 5309.8. Was that what it was? Yeah, 5309.8 liters. Okay, at end of 24 hours. Okay, so the reason I had to times this by 60 is again because this is liters per minute. Okay, so liters per minute. So I would have to times this number over here by 60. Okay, because again, the rate of flow is per minute, 1.1 liters per minute. So I have to times that by 60 to then find the liters in hour 2. So that's why I times this answer by 60. Okay, that was our answer over there. So careful with that one, it's a bit easy to miss. As I did, I nearly missed that. So for part B, they say for the quadratic sequence, the following information is given. Okay, so let's not miss it. We're dealing with a quadratic sequence, and they tell us that T1 minus T2 is 4, T3 minus T2 is 7, and T10 is 0. Determine the nth term for the quadratic sequence. Okay, so we know that T2 minus T1 is 4. Okay, so here we have T1, here we have T2, T3, and yeah, that's what we have, right? And they tell us that T1 minus T2 is 4. So they're saying the difference between here is 4, and the difference between T3 and T2 is 7. Okay, so here we have the first difference over here. So we know the first differences are 4 and 7. So the second difference there is obviously 3. Okay, so the general formula for a quadratic sequence is an squared plus bn plus c. Okay, so to determine the nth term of the quadratic sequence, we're going to have to know a, b, and c. Okay, so we know that 2a is equal to 3. So we know that a is 3 over 2. All right, then we know that 3a plus b is equal to 4. Okay, this is just theory that you need to memorize. Well, these formulas you need to memorize because they're not on the formula sheet. Okay, but I know what a is, so I have 3 times 3 over 2 plus b is equal to 4. So b is equal to, if I go to my calculator, I can say 4 minus 3 times 3 over 2, which is negative a half. So b is negative a half. Okay, negative 1 over 2. All right, so normally how you would find c is then looking over here. Okay, but we can't do that because we don't know what T1 is. But what information haven't we used yet? We haven't used that T10 is 0. Okay, so let's fill in what we know about Tn so far. We know it's 3 over 2 n squared minus 1 over 2 n plus c. All right, so what I can do here is I can substitute that T10 is 0. Okay, so I can substitute Tn is 0. So I know that n is 10 in that case. Okay, so I have 0 is equal to 3 over 2 10 squared minus a half times 10 plus c. Okay, so c is equal to, so in my calculator what I'm going to do is, let me just move the calculator over here. What I'm going to do is 3 over 2 times 10 squared. So this should be negative when it goes to the other side, plus a half times by 10. Okay, so I get c is negative 145 from that. Okay, so c is negative 145. So there we have Tn, the formula for Tn. Let's just make sure we write it. The nth term is given by 3 over 2, that's a 3, n squared minus a half, n minus 145. So there we go. That's what they needed for that question. Then for C, they say the first term of a converging geometric series is equal to the common ratio. If the sum to infinity is 1 over 5, then calculate the value of the first term in the series. Okay, so we know we're dealing with a converging geometric series, okay, and that means we can use the sum to infinity equation, but they've basically told us the sum to infinity already, and they say calculate the value of the first term in the series, which is a. But they also tell us that the first term is equal to the common ratio, so we know that r is equal to a. All right, so let's write out the formula for the sum to infinity. It's 1 minus r, like this. All right, but let's fill in what we know. We know that the sum to infinity is 1 over 5. We have a, and we know that r is equal to a. So what we do is we have this, right? So what we can do is we can cross multiply and get 1 minus a is equal to 5a. And then what we're going to have is 6a is equal to 1. So therefore a is 1 over 6. Okay, so that was just some easy algebra. Okay, so don't let these things confuse you. Just keep it super simple. Keep it super simple. Remember this acronym, KISS. Keep it super simple. Okay. Let's look at D and also think about our acronym. So they say the geometric sequence given. Okay, again, don't miss that it's geometric. So they give us x, y, and x plus y. So here's term 1, 2, and 3. And x is greater than 0 and y is greater than 0. And they say determine the numerical value for x over y. Okay, so let's see what we know. Okay, so what we do is we know that t2 over t1 is equal to t3 over t2. Okay, because for geometric sequence, there's a common ratio. Okay, so t2 is y, t1 is x, t3 is x plus y, and t2 is y. Okay, so let's see how we can roll with this. So what we can do at this point is we can actually split this fraction. Okay, so we can write it split like this. Okay, so we can say that y over x is equal to x over y plus y over y. Okay, so what we get then is y over x is equal to x over y plus 1. Okay, so at this point, the issue is here we have y over x and here we have x over y. So let's work over here and let's say let k equal to x over y. Okay, so what is this then? So this is the inverse of this fraction. So that is 1 over k. So 1 over k is equal to k plus 1. All right, so what we have now then is we can multiply everything by k. So we get 1 is equal to k squared plus k. And if we rewrite this like this equals to 0, now we can solve for k. So the issue here is we can't factorize this normally, so the calculator is going to have to come out. So here we have the calculator, we go mode 5, I didn't press mode, sorry, mode 5, 3, 1 equals 1 minus 1. So we're going to get some answers for k here. So we're going to get k is equal to minus 1 plus root 5 over, what was it over? Over 2. Or k is equal to, and the other answer here is minus 1 minus root 5 over 2. Okay, so those are the two possible answers, okay? But remember, k is up here, x over y, all right? So these are two possible values for x over y, okay? Because remember, this is x over y, and this is x over y, okay? But we need to be careful now. We need to check, okay? So x is greater than 0 and y is greater than 0. So that means that x over y must give us something that's positive. Okay, so let's put this in the calculator and see what we get. Okay, so what I can actually do is I can just go here and press, change it to a decimal. So I know this is 0.6, okay, to 1 decimal place, which is positive. That's fine. if I convert this to a decimal, I see it's negative 1,6. Okay, so this answer is not valid, okay, because of this restriction over here, where x over y has to be positive. Okay, so just like before, we have to check our answers at the end. Okay, so then we say, therefore, x over y is equal to negative 1 plus root 5 over 2. All right, that's the numerical value of x over y. So I know this was not very straightforward, what I did from here on. So this is a straightforward step. But then what I did here was maybe not so straightforward. But again, I had to fight to get it into a form that was usable for me. Okay, I see what the memo did is they did the same thing. So their step 1 was the same, and then they got to this point over here, but then they didn't split this. They didn't split this fraction. What they did is they cross multiplied. Okay, they cross multiplied, and then they got some quadratic, and then they solved that for x, and then luckily that ended up dividing by y. You can have a look at what the memo did. For me, it wasn't so straightforward. I wouldn't have seen exactly what the memo did, but for me, I would have worked from this form, and then I would have fought this form to get it into something that was usable for me. So I needed y over x's and x's over y. Okay, so that's why I saw that we can split this denominator like this. Okay, that's what made me realize we can split this denominator. Okay, because I know my eyes were looking for y over x and x over y's. Okay, and then I did this to make the problem easier to solve. Okay, so this was not a straightforward question. This is my method, which for me was easier to see than the memo. Okay, so if you're confused by this question, take some time to think through or look through this again. It was not straightforward. It's not something that was taught to you before exactly. It was a bit of a problem-solving question. Okay, but the main thing is step 1 was relatively straightforward, and then you needed to fight from there to deal with this x over y. Okay, so I know it's maybe not the best explanation I can offer there, but yeah, the question itself is not straightforward. So we needed to work with it to get it into a form that was usable. Okay, that's the best I can really say regarding this problem. But I hope you realized that once we got here, remember I was looking for y over x's and x over y's. That's why I did it like this. And then I saw when I got to this step, well, these things are just inverses of each other. So let me make this k, so then this will be 1 over k. All right, so I hope that was a bit helpful. Okay, then question 11, we're moving over to conditional probability. So they say after some research, you decide that the best option for your online security is to have 2 unique passwords before opening important documents. The first 10-digit password consists of 2 parts. So the first part is made up of 6 numbers. The numbers that can be used are the numbers 1 to 9. How many unique 6-digit codes can be created if repetition is allowed? Okay, so there's a 6-digit code. All right, so there's 6 possible places we can put numbers, and 1 to 9 there's 9 options there. Okay, so there's 9 possible numbers that we can put in here. Okay, so in this first slot of our code, how many digits can go in there? Okay, so there's 9 possible digits that can go in here. So the number of options we can put as the first number in our code is 9. But the thing is, repetition is allowed. So there are 9 options that are available for the second digit in the password, and 9 and 9 and 9 and 9. Okay, 9, sorry. I said 9, wrote 6. So what we do is we just multiply all these options. Okay, so again, in the first slot, there are 9 possible digits that can be in there. Okay, because 1 to 9, there are 9 options over there. So this is just going to be equal to 9 to the 6. Okay, and you can leave your answer like that. Okay, you can leave your answer like this. You don't have to give it as like an actual number. If you put in your calculator, you'll get 531,441. Okay, but either one of those are fine. Now they say the second part is a 4-digit code compiled from the digits 1 to 9, so that is still 9 options for us. And repetition is not allowed here. Okay, so very important, repetition is not allowed here. And now they say how many even 10-digit passwords? Even 10-digit passwords can be created by combining these two parts. Okay, so we need to combine these two parts. Okay, so it's a 10-digit password. Okay, so there's 10 slots for us to put these digits in. So how many you have there? 5, 6, 7, 8, 9, 10. All right. So in the first part of the question, we dealt with the first six numbers. Okay. Now what we're going to be dealing with is the first 6, but then also the next 4. Okay, because the second part is 4 digits. Okay, so let's deal with the first 6. 1, 2, 3, 4, 5, 6. Okay, so here's the first 6 over here, and then here will be the last 4. Okay, so we know that for the first 6 nothing's changed. The first 6 comes from here, so it's the exact same. So repetition's allowed for the first 6. Okay, so again, there's 9 options for each of these slots. Okay, so for each of these 6 slots, there are 9 digits that can go into these. Okay, so yes, so I'm not saying that here we have the digit 9 again and again and again. I'm saying in this first slot, there are 9 options. Okay, so we can have a 1, 2, 3, 4, 5, 6, 7, 8, or 9 in the slot. Okay, so you'll see that's 3, 6, 9. So there are 9 options that can go in that slot. Okay, so I hope that clarifies that. Now let's look at the second part that's a bit new. Okay, so we know that with these 4-digit codes, okay, this 4-digit code, repetition is not allowed. Okay, so it's 1 to 9, but repetition is not allowed. And then very important, it needs to be even. Okay, so let's look at how a number can be even. Okay, so if a number is even, we're going to have either a 2, a 4, a 6, or an 8 in this last slot. Okay, so how many options is that? 4. There are 4 options that can go into here that will make it even. All right, now let's analyze just looking at this last 4. Okay, so with this last 4, repetition is not allowed in the last 4. Okay, repetition is not allowed. So if we use one of these 4, okay, if we use one of these 4 to go into here, how many digits are left? That means we have 8 other options that can go into one of these. Okay, so for example, what I mean by that is, say there was a 2 in here. Okay, say there was a 2 in that last slot. So remember, here's the number of options, but let's say we ended with a 2. Okay, so if we end with a 2, what numbers do we have left in our pool? Okay, we have a 9. Well, let me start. We have 1, 3, 4, 5, 6, 7, 8, 9. Okay, so if you count this, how many options do we have left? 8. We have 8 options here. So over here, we can have 8 numbers. Okay, but now that we've chosen one of these 8 numbers, this one, we only have 7 left in our pool. Say, for example, there was a 1 over here. Okay, so let's say, if we continue with this code, let's say we had a 1 over here. Okay, so if we put a 1 in there, then now, instead of this 8 options like we had before, now in this next slot, we only have 7 options. Okay, because now this is 7 numbers. Okay, now let's say if we put a 5 in that slot, right? So now instead of the 7, we've got rid of this 5. You can see here we have 1, 2, 3, 4, 5, 6. So only 6 numbers can go in here. Okay. So yeah, let's say for example, then this is a 7. We choose a 7. Okay. So then this would be a 6. All right, because here you can see, if I count this again, we have 1, 2, 3, 4, 5 options. Okay, yes, because this we chose a 7, so that's why I crossed out the 7. Okay, so I hope that makes it a bit more clear. All right, so that is what's happening over there. Okay, that's what's happening in this part over here. Let me change this to orange so things are more clear for us. Okay, so now we need to combine everything for the 10 digits. Okay, so if we look at the first 6, this is 9 times 9. Remember, we're timesing all of these things. Okay, so we times everything. So feel free to put all of this times in your calculator. But what will be easier if I go to the calculator view is if I do 9 to the power of 1, 2, 3, 4, 5, 6, 9 to the power of 6, times by 8 times 7 times 6 times 4. 8 times 7 times 6 times 4. Okay, so you could either write this thing here at the top in your calculator or this answer over here, which is what, 71 million? 714 million. Okay, that's a big number. Okay, so I'll write it for us. So 714 256 704 256 256 704. Okay, so let me just address something here quickly. So again, some of you might be saying, okay, but look, here's our pattern 8 7 6. Why is this not a 5? Okay, but remember, it has to be even. So in this last slot, how many numbers can go in here? It has to be a 2, a 4, a 6, or an 8. How many options are here? 4 options. That's why there's a 4 there. Okay, but if we've used one of these options, okay, how many then do we have in this slot? We have 1 less than the total of 9, which is 8. Then if we've used 2 now, how many are left? 7. Now if we've used 3, how many are left? 6. Okay. So I hope something has clicked in your mind if you have struggled with these before. All right, let's move on. Question 2, they say the second 9-digit password has to be greater than 600 million with the last digit being divisible by 3. How many 9-digit passwords are possible if you use the digits 1 to 9? No repetition is allowed. Okay, very important, no repetition is allowed. So let's look at one of them, okay? So we have 9 digits, so 3, 6, 9, okay, 9 digits. Oh, well, yeah, 9 digits here. And so we're still dealing with, over here, we're still dealing with, this is part 1, this is part 2. So yes, we're still dealing with 1 to 9, so digits 1 to 9. Okay, there's some other conditions here where it has to be greater than 600,000. Okay, 600 million rather. So let's look at one option. Let's say we start with a 6. Okay, so if we start with a 6, what does the last digit have to end with? Okay, so it either needs to end with a 3 or a 9. Okay, it either needs to end with a 3 or a 9. All right, so let's look at this together. So how many options do we have to end with? 2, right? It's a 3 or a 9. And if we're starting with a 6, there's only one possible digits that can go in there. It's only the 6 that can go in here. So this has to be a 6, this can be a 3 or a 9. Okay, that's why that's 2 over there, and that's why this one, there's only one number that can go into that slot. All right, so let's see, out of these, if you can use the digits 1 to 9, we've already used 2. Okay, so 1 to 9 means we have 9 options. We've already used 2. Okay, this slot has been taken up by a digit, and this slot's been taken up by a digit. So how many are left over? There will be 7 left over. Okay, so when I start counting over here, it's going to be 7, 6, 5, 4, 3, 2, 1. Okay, so I hope that makes sense over there. All right, so this is when we start with 6. Remember, we're starting with 6 because it needs to be greater than 600 million. Okay, and we know that it has to end with a 3 or 9 for it to be divisible by 3. Okay, we can't have a 3, a 6, or a 9 here because remember, we're starting with 6. All right, so if you do this, what you'll do is, remember, we just times all of these. Okay, so this is just 7 factorial times 2. Okay, because we're timesing 9. Okay, now let's look at if we start with a 7 or 8. Okay, so the reason I don't want to start with 9, because start with 9 will be an interesting case. So to be honest, you could even split it like this. Start with 7. Okay, let me show you how if we start with a 7. Okay, so remember, we have to start with 7 because that will mean if we start with 7, the code will definitely be greater than 600 million. Okay, so if we start with 7, that means we can end with a 3, 6, or 9. 3, 6, or 9. Okay, so I should be saying or. Okay, So again, 9-digit code over here. How many options can we end with? We can end with 3 options, a 3 or 6 or 9. How many do we have for the first slot? 1, because we have to start with a 7. All right. So if we do this, so we've used 1 digit over here and we've filled the slot with 1 digit. So we filled the slot with 1 digit and we filled this one with 1 digit. So how many do we have left over? Remember, because in this last one, in here can be a 3, 6, or 9, and here has to be a 7. Okay. So if we choose one of these, okay, remember only one of these to go in here. And if we choose, well, we don't have a choice that to go in there. Out of the total of 9 digits we had before, we have now 7 left over to play with. Okay, that's why this is 7, 6, 5, 4, 3, 2, 1 again. Okay, so what this becomes then, what you guys should realize now is, again, it's 7 factorial times 3. 7 factorial times 3. Okay, what you'll see is if you start with an 8 and end with 3, 6, or 9, you'll get the same thing again. So you can times this by 2. Okay, but let me also show you what would happen if we have the same conditions, right, that we're ending with, but if we realize that we can start with a 7 or 8. Okay, if we can start with a 7 or 8 or combine it in 1, how many options do we have here for this first slot? We have 2 options. It can either be a 7 or an 8. Okay, so if you combine this in 1, what you'll see is it will just be 2 times 7 factorial. Let me all put this in one color for us. It's going to be 2 times 7 factorial times by 3. Okay, which would be the same as if you, what we did before, right? If you treat them separately. Okay, so that is what we have over here. So we're going to have to add these at the end, but we still need to look at if we start with 9. Okay, if we start with a 9, we can end with, what can we end with? A 3 or 6, right? All right. Because remember, no repetition. So if I start with a 9, that means I can't use it to end with. Okay, but anyways, we have 9 digits, well, 9 slots for digits. We have to start with 9, so there's 1 option. We have 2 options for this end slot, either a 3 or 6. So now we had 9 digits, we filled 1 slot, we filled another slot, we filled 2 slots. How many cards do we have over? How many digits do we have over? We have 7 here, then we have 6 because we've used now here 5, 4, 3, 2, 1. Okay, so this is 7 factorial times 2. Okay, so for the final answer, right? So for the final answer, you need to put everything together. Okay, you need to add all of these together. So you can say then, you can say therefore total, let's make sure we're answering the question. So that's the wrong part. You can say how many digits are possible. You can say therefore total possible combinations, total possible codes, total possible passwords is, and then what we're going to do is we're going to show how we're adding everything. So it's going to be 7 factorial times 2. So it's 7 factorial times 2 plus what we got here. Okay, so plus 2 times 7 factorial times 3 plus this last one that we did on this page, 7 factorial times 2 plus 7 factorial times 2. Okay, and then that will give us, this one I recommend putting in the calculator and getting a final answer because it's a combination of different things. Okay, so yes, so times 7 factorial times 3 plus 7 factorial times 2. Okay, so 50,400 as a final answer. So the total possible passwords that meet this criteria is 50,400. Alrighty. Let's now look over to B. So B is a separate part now. B is separate to the conditional probability we have just been doing, the fundamental counting principle. So if we look here at B, they say we are given a regular 2-sided dice, and one is red and one is green. You throw both of the dice at the same time and record the values. So G is the value on the green dice and R is value on the red. So once you've thrown these two dice, you place the values into an expression for f of x, which is this. What type of function is this? This is a parabola. Okay, this thing is a parabola, and it will look like this. One of the roots here will be at negative g, and the other root will be here at r, positive r. Okay, so we know our parabola will look something like this. Okay, that's important to identify. Okay, so I know things are looking very weird right now, but keep it simple. Look at the basics. It's just a parabola. All right. Now they say, what is the probability that the y-intercept for the graph of f will be less than negative 29? Okay, so how do we find the y-intercept of this thing? So you make x is equal to 0. Okay, so f of 0 is equal to 0 plus g and 0 minus r. Okay, so if you times this, it's negative gr. Okay, it's just negative times gr. This is the y-intercept. Okay, this is the y-intercept. Is this thing over here, negative gr. So we know that if you times g and r together, right, because remember g is the roll on the green die and r is the roll on the red die, this needs to be less than negative 29. Okay, so if you times the die together, the values of the dice or die, it needs to be less than 29. Okay, so let's have a look. Let's put the values for the green dice over here. 1, 2, 3, 4, 5, 6. Okay, so that's what the green dice can roll. Let me actually use colors. Okay, so the green dice can roll this. It can roll a 1, a 2, a 3, a 4, a 5, or a 6. Okay, that's what the green dice can roll. Now let's look at what the red dice can roll. 1, 2, 3, 4, 5, 6. Okay. So what I'm going to be doing here is I'm going to make a table. Okay. So remember, because we're going to times these die values. Okay, this thing where you times two dice has come up before in other past papers. Okay, so learning or understanding how we do this table could be helpful. Okay, so essentially what I'm doing here is I'm just saying this value times this value will go here. Okay, so 1 times 1 is 1. Let me put this in orange. And then 1 times 2 is 2. 1 times 3, so you kind of see what's happening here. Okay, now I'm doing 2 times 1. So that's 2. 2 times 2 is 4, 6, 8, 10, 12. Okay, 3, 6, 9, 12, 15, 18, 4, 8, 12, 16, 20, 24. Then 5, 10, 15, 20, 25, 30. All right, and then 6, 12, 18, 24, 30, 36. Okay, so these are all the possible combinations of if we multiply the green die and the red die values, the red dice and the green dice values. So the total number we have is this 6 rows and there are 6 columns. So the total combinations is 36. Okay, in total, right? You can count or you could do 6 times 6. All right, now we need to see how many are less than 29. Okay, so there are quite a few less than 29. This. So let's look how many are more than 29. Okay, so we have more than 29. 1, 2, 3. So 3 are more than 29. Okay, so what is the probability? So if 3 are more than 29, how many are less? Okay, so 33 will be less, okay, than 29. But we actually need to be careful here. So here they're saying less than negative 29. Okay, so less than negative 29. So what values are less than negative 29? Okay, so negative 30, negative 31, these are all less than negative 29. Okay, so because remember, if we go back to when I drew the parabola, I'll draw it here. Okay, so the parabola will look something like this. Okay, but the thing is here we have negative 29. We want to be less than that. Okay, So we want to be less than that. So what we actually need to realize is we're actually looking for these values. Okay, because if you times 5 times 6 over here, what you're going to get is actually negative 30, which is less than 29. Okay, so the actual answer here is there are 3 over 36. That would be the probability, which is 1 over 12. Okay, because we're looking for less than negative 29. Okay, so numbers that are less than negative 29 are negative 30 onwards, negative 31, negative 32, etc. Okay, so we need to actually look at the numbers. So essentially you're looking for things that are bigger than 29. Okay, we're looking for bigger than 29. So more like this, we're looking for we're looking for bigger than 29, which is 30, 30, and 36. So 3 out of the 36. So this is our probability, either one of these. Okay, because again, less than 29. Okay, so that one was a bit tricky. Now for number 2, they say, what is the probability that the roots of f equals 0 will be real, rational, and unequal? Okay, it's for 1 mark. All right, so 1 mark, you should be able to read it off immediately. Okay, what you could have done is you could have done nature of roots, which would have taken you more time, and I don't recommend if it's for 1 mark, okay, to go into nature of roots. So let's see, when our roots are real, rational, and unequal. Okay, well, let's look at our f of x. Okay, where do they give us f of x? Well, they give it here. So here we have f of x. All right, so we know g. So we know our roots here are x is equal to negative g or x is equal to r. Those are our roots. Okay, so g and r, remember these can only be 1, 2, 3, all the way to 6, right? So those values are always real and they're always rational. Okay, they're integers. So we know that those roots, whatever number we choose, will be real or rational. Okay, but when the roots are unequal, well, the thing is we can never have equal roots, because even if both of them roll on 1, one of the roots is going to be x is equal to negative 1, and the other root is going to be x is equal to positive 1. So the roots will never be equal. They will always be unequal. So the probability is literally 1. 100%. Okay. Now for question 3, they say if h of x is given by that, then what is the probability that if you throw the 2 dice and place the values into hx, that the roots of hx equal to 0 will be non-real? Okay, so this thing is given in turning point form. So let's expand this out so we can look at when the roots are non-real. So remember, when roots are not real, we have that the delta is less than 0. Okay, so but to find our delta, we need b squared. Well, we need b, a, and c. Okay, and it's hard to see in this form over here. So h of x is equal to minus 1 x squared plus 2xg plus g squared plus 4 minus r. Okay, so that gives us negative x squared minus 2xg minus g squared plus 4 minus r. Okay, so you can see here that a is equal to minus 1. Our b is equal to whatever is in front of x. So what I should write this actually as, should write it as 2gx, 2gx. Because remember, the b is the coefficient of x, which is negative 2g. This is what's in front of the x. There's the x, what's in front of it is that. Okay, then all of this is our constant. Okay, so c is equal to minus g squared plus 4 minus r. All right, so for our delta, we know that it's b squared minus 4ac. So that is negative 2g squared minus 4. A is negative 1, and our c is minus g squared plus 4 minus r. Okay, so that is 4g squared minus, so that becomes plus 4 negative g squared plus 4 minus r. Okay, so if we continue with that, we're going to get 4g squared minus 4g squared plus 16 minus 4r. Okay, so what you'll see there is things are going to cancel, these things in particular. So what we left is delta is equal to 16 minus 4r. Okay, but remember, we know that delta has to be less than 0. Okay, so we have 16 minus 4r is less than 0. And what that means is we take that 4r to the other side and we get this. We divide both sides by 4 and we get that 4 is less than r. Excuse me, is less than r. So when we will have non-real roots when r is greater than 4. Okay, or 4 is less than r. So this you could read as r is bigger than 4. So remember, r is a roll of a dice. So what numbers are bigger than 4 on a dice, right? 5 and 6. So the probability there is just 2 over 6, which is 1 over 3. What you also could have done here is you could look at the form of this parabola. Okay, it's given in turning point form. So the general look of it would be, so we have, this is a negative. So we know the general form is going to look something like this. So we don't know exactly where it turns. It could turn here, it could turn there, it could turn over here. But the main point is, when will the roots be non-real? Okay, so we know for a parabola, when the roots are non-real, that means that we need to be below the x-axis. Okay, we need to be below the x-axis. So something like this, something like that. The main point is we're turning below the x-axis. Okay, so it doesn't matter where we are horizontally along the x. It doesn't matter the x coordinate of the turning point. What matters is the y coordinate of the turning point. Okay, and what tells us the y coordinate of the turning point? This is the y value of the turning point. Okay, so what happens is, here we have x. Okay, we need, and this is the x-axis or y-axis. So we need to be below the x-axis. Okay, so this thing has to be less than 0. So 4 minus r has to be less than 0. Okay, and then we get to the same thing that we just got with when we did the nature of roots. We have that r has to be bigger than 4. Okay, and we get to the same conclusion. Okay, so you could have also done this way for that question. All right, now for the final question. So the final question in math paper 1 is optimization. Okay, so it's normally always optimization. So I have a video on how to optimize, and I go through some examples on my channel. But yes, you'll see the steps for optimization. We're going to look at them here. So basically you need one equation that is going to have two variables. But what you need to do is you need to eliminate one of those variables by subbing into that equation. So you have an equation with one variable that you can differentiate to optimize it, but you need to get rid of one variable. So just keep an eye out on that as we approach this problem. So the general method. But if you need more information, as I said, I have a video. All right, so let's have a look. So here is the front view of a rectangular storage facility. It's built onto a wall represented by MO. Okay, so MO is here, it's the wall. They say the roof is attached to the wall at M. So MO is 6 meters. Okay, so this whole distance is 6 meters. The gradient of the roof MN to NP must have a ratio of 2 to 5. Okay, so MN is here and NP is here. Okay, so if this is 2 times some factor, 2K, then this has to be 5 times more than that. Okay, it is in a ratio of 2 to 5. Okay, so if somehow this is 2 meters, then this one will be, well, 2 to 5. This one will have to be 5. Okay, so yes, that's how that would work. They say PR is a vertical beam over here, NP is a horizontal beam over there, and OR represents the ground. All right, let's get into the question. They say determine the equation of the line MP that represents the roof. Okay, we need this equation over here. Okay, the thing is, we know the coordinate of M. We know the coordinate of M is 0, 6. Okay, because this whole distance is 6 units. So we have a coordinate, we just need the gradient, okay, of line MP. The thing is, we do know the gradient. We know that this is 2, and this is, so we know that we rise 2 and we run 5. Well, here we're dropping 2 and we run 5. Okay, so we know the gradient is negative 2 over 5. Okay, because change in y over the change in x. Okay, so we're dropping 2 units in the y and then running 5 units in the x. Okay, so that's why it's negative 2 over 5. Okay, So we have that. So now what we do is we just sub a point. So we have y is equal to minus 2 over 5x plus c. And we don't even have to sub a point because we know what our y-intercept is. It is just plus 6. So that would be the answer over there. Okay. Some students might not see that this is a negative, but just remember that this is how a negative gradient looks for a straight line. Okay. Cool. Now for 6 marks, last question of the paper, we're given this. So they say below is the rectangular storage facility under the roof MP rather. So this is the storage facility in 3-dimensional form. They say if the depth of the rectangular storage facility over here is 2 meters shorter than the width. Okay, this is very important. Okay, this is our relation that we need in optimization. Then determine the length of the vertical beam. So we need the length of this thing, so that the rectangular storage facility will have a maximum volume when placed under roof MP. So we know we need to optimize because they're talking about maximum volume. What do we need to maximize? Volume. So we're going to need a formula that has volume in it. Okay, we're going to need a formula, not even that has volume in it, sorry, we need a formula for volume. And then what we're going to have to do is differentiate the variables in that. Okay. And they say the roof must remain fixed at M and the ratio of Mn to Np must remain 2 over 5. What 2 is to 5. Okay, this is in bold. Very important. Okay, very important. So let's do some things. Let's sort out over here, this important thing over here, and this important thing over here. All right, so what are we solving for? We need to determine the length of the vertical beam. Okay, so we need to determine the length of this. So here's a vertical beam. Let's call it L, okay, for length. Okay, so the vertical beam is L. All right, now let's see what else we know. So if we call the width over here, if we call it W, all right, so we have LW, and here depth. We can call the depth D, but let's not do that because what do they tell us about the depth? How's the depth related to one of these variables? We know that the depth is 2 meters shorter than the width. Okay, so what we have is, we know that the depth, all right, is W minus D. Okay, so what we should say is let the distance PR be L and let the width, we can say let width be W. Okay, so we can say that just to be fancy or just so the marker knows what's cracking. So we know that then the depth is equal to W minus 2, okay, because it's 2 meters shorter than the width. Okay, 2 meters shorter than the width. All right, so let's say we go into volume here. Okay, so if we get the equation of volume, remember it's just length times depth times width. Okay, or length times width times depth. Okay, but essentially, so it's L, our length, times by our width, times by our depth. Okay, but we know what our depth is in terms of W, right? It is W minus 2. Okay, let's say times W minus 2. Okay, so now we're making progress. Before we had 3 variables where we had D, W, and L. Now we only have 2 variables. Okay, but the problem to optimize this, we need it to be 1 variable. Okay, so we need a connection between the length and the width. We need a connection between the length and the width. Okay, so that's where this information in bold is probably going to come into force. Okay, so they say that Mn to Np must remain 2:5. Okay, so here is Mn and here is Np. Okay, but we know Np is the same as our width. Okay, so we know that Mn over Np is equal to 2 over 5. Okay, but we know that Np is the same as our width. Okay, it's the same as our width. So we know Mn over W is 2 over 5. Okay, but now we need to think, how can we relate Mn, right, this distance, to another part of our storage facility here at the bottom? Okay, so we related this beam up here to our width. Now we need to relate this distance over here with the length or something else. Okay, the thing is, we know this total distance is 6, right? And what is this? this is our length, right? Because this is our length. I called that the PR is L. So this is L, right? So I know what is MN then. If the whole thing is 6, then this must be 6 minus L. Okay, so what we have is 6 minus L over W is 2 over 5. Okay, that's our connection to get rid of one of these variables. So let's see, what are we trying to solve for again? They're trying to solve for the vertical beam. Okay, so we're trying to solve for PR or L. So we're trying to solve for L. So let us make W the subject of the formula. Let's make W the subject of the formula. Okay, so I'm going to rock with this on the next page. All right, so we had 6 minus L over W is 2 over 5. Okay, so let's cross multiply here. So we're going to get that 6 minus L. I know those look like E sometimes, sorry guys. But anyways, so 2W. So we get 30 minus 5L is 2W. All right, and what we want is this volume expression. Right now, I think it'll be easier if we get L in terms of W, because here's a W, here's a W. Okay, so let's get it in terms of one variable. So it'll be easy to get L. This is a tough one. So what I mean by this is we need this thing to be in one variable. Okay, so it either needs to have all L's or all W's. So we have a choice here. We can either have W is equal to something or L is equal to something and then substitute in here. Okay, so I'm gonna go with what I feel is easier right now, which for me, I think is W. I'm gonna make W the subject of the formula. So I divide both sides by 2. Okay, so that's 15 minus 5 over 2L. That is my width. Okay, so that is my width. Okay, so now I can replace every time I see a W. Okay, so this is what ended up happening from that equation. So whenever I see a W, I can replace it with an L. Oh, sorry. Whenever I see a W, I can replace it with this thing over here. Okay, so let me do that. Let me do that now. So I have that volume is equal to L times, and W is, again, this is W, 15 minus 5 over 2L. Okay, I just want to say here, it didn't matter if you were working with this or if you started working with negative 5L is equal to 2W minus 30, and then if you did L is equal to minus 2 over 5W plus 6. Okay, and then if you substituted, if you got rid of the L, so it didn't matter which one you worked with. Okay, I just want to state that as a fact over here. Okay, I just worked, this is, the main point is this needs to be with one variable. Okay, one variable. All right, so then W is again 15 minus 5 over 2L, and then we minus 2 from that. Okay, so let's keep working with this. So we're going to get that L 15 minus 5 over 2 times L, and then this is 13 minus 5 over 2L. Okay, so the thing is we're going to have to differentiate this volume. So let's get it in, let's expand everything out. Okay, so if I expand everything out, I get V is equal to 15L minus 5 over 2L squared, and then this bracket stays the same. I'm going to distribute now though. Okay, and then I'm just distributing here. So essentially I'm just foiling this out in this next step. Okay, let me use green here. Okay, so that gives me 15 times 13. What is that? 15 times 13, 195. So I have 195L. And then let me show you in the calculator what I'm doing here. So what I'm doing in the calculator is I'm doing 15 times by negative 5 over 2. Easy as that. So that just gives me minus 75 over 2, careful now, L squared, because L times L. Okay, and my L's are getting worse. Okay, and then what we get here is we have, well, we just have now 13, right? 13 times negative 5 over 2. So this is negative 65 over 2. Yeah, negative 65 over 2, L squared. And then if you multiply those, it's just negative 5 over 2, that thing just squared. Okay, because it's this times that. So that's positive 25 over 4 L to the power of 3, L cubed. All right, let's collect like terms to get a final expression just for volume in a nice form. So you can see here we have a cubic. So let's arrange in descending powers of L. So we have this. So for the middle terms, we can have minus 75 over 2 minus 65 over 2. That gives us negative 70. So minus 70 L squared. And then we're going to have plus 195 L. Okay. So now what we need to do is we need to differentiate this. Okay. So what we do is we take the first derivative. So we're differentiating V with respect to the variable L. Okay. So we're differentiating V with respect to the variable L. Okay. So here, let me just put this for us. So yes, we're differentiating V with respect to L. Okay. And here's our V. Okay. So we apply our normal rules of differentiation, right? So what we're going to do is that 3 comes forward, our coefficient stays there, and then what we have is L squared minus 2 times 70 L plus 195. Okay, that L falls away. Okay, now if we roll with this, what we're going to get is 75 over 4 L squared minus 140L plus 195. Okay, that's what we get there. And now we need to realize for maximum, right? For maximum volume, we have to set this equals to 0. Okay, so all you do now is you just say, well, 75 over 4 L squared minus 140L plus 195 is equal to 0. Now we can use the calculator. Okay, because this is just a trinomial, and we can use the calculator to solve trinomials. Okay, so mode equation 5.3, 75 over 4, negative 140, don't forget the negative, 195. Okay, so the two lengths that we get is we get L is equal to 5,6, okay, to 1 decimal place, or L is equal to 1,9 meters. Okay, so very interesting. Both of these answers look valid, right? Because normally sometimes you'd have a positive length and a negative length, and then you can be like, okay, well, obviously we can't have a negative length. But very interesting here, both of the lengths are positive. Okay, so a lot of this paper, what you've seen before, is when we get our answers, we need to check. And it's always a good habit to check your answers, right? There's been times when we need to decide, okay, what's valid, what's not. Okay, and this is, again, another situation. Okay, so how do we know what's valid and what's not? Okay, so let's look where we had an equation for W. Okay, let's look where we had an equation for W. Okay, so it came from here. Remember, this one we didn't use. Okay, this one we didn't use. It came from here. So let's plug in our L's, right? Let's plug into our L's to this and see what we get. Okay, so if we go back to the calculator, and what we do is we say 15 minus 5 over 2, and then this one, we'll try the first one first, 5,6. We get that our width is 1. Okay, right? So let's do this rather. Let's say, okay, well, if this is our answer, then width is equal to 1. And if this is our answer, our width is equal to, and what we'll get there is just 1.9, right? Which is 10,25. 10,25. Okay, now where did we use W, right? Where did we use W? So we used W over here. The depth is 2 meters shorter than the width. So do you see how this is not valid? Because the depth is going to be W minus 2, which in this case is going to be negative 1, right? Because our width is 1. So this is not possible. So this answer is not possible. So therefore our length is 1,9. So let's make sure we know what they were asking and we answer what they were asking, right? So if I get to maybe here where it was a bit clearer, they say determine the length of the vertical beam, the length of PR. Okay, and again, what did I call PR? L. So here I have solved for the length. Okay, so let's make a final statement, and we can say therefore the length of, let's just make sure we know exactly what they're asking, the length of the vertical beam. Therefore, length of vertical beam for maximum volume is 1,9 meters. So yes, always make sure you know what they are asking in the question, okay? Because if they're asking for the width, you would have to state this. Okay, so that is the end of the paper. I hope the video was helpful, and I'm wishing you guys all the best.